Welcome to Prelim Preparation 2026. So this is going to be your preparation to this year's trial. Reason why I did this is that I went through the past papers for trial. They're a little bit trickier compared to the normal November paper. So I wanted you guys to be well equipped for your trial, as it contains a lot of marks in terms of like your final mark. So, and also the nice thing is that if you can master this and if you can do well in your trial exam, that means the fact that your November you have less stress. So that is why I decided to do this. So I have a recording schedule, right, or a release schedule on which when each paper is going to be released. So the preparation is going to start now, as you see in this video. So this is the release schedule, right? So it's within each date. So as you can see, the fact that we have June when each paper is going to be released, right? And also we have like July, right? As you can see, July is going to be like double releases because of like it's close to August, because then you have 1 month. And then we have lastly August, which is going to be this, completing the entire trial papers from last year. So this was very important for me to make sure the fact that by the time you guys write your trial exam, all the provinces are covered, right? Welcome to Eastern Cape Paper 2. As you know, the fact that this video has a PDF version of it, and that PDF version of it is going to be available in the membership. So now I'm going to show you on how to join the membership and also on how to get the PDF. So first I'm going to show you guys on how to join the membership. Obviously, you're going to search my name, then you're going to click on my profile, then you're going to land here, right? Then you have two buttons. You have the subscribe button, right? And you also have the membership button, right? So the join button is where you join the membership. So when you click on it, right, you'll see the fact that this is going to be the membership, right? Then it tells you what you get: membership only videos, early access, you get it, priorities, and all that, right? So now, do you see the fact that we already have exclusive content, right? So this content is strictly on the membership, right? So now when you say join membership, it's going to load, obviously. Then let me just say yes. Then it's going to load. Then when it loads, do you see the fact that now you're part of the membership, right? So when you scroll down, right, is that you're part of the membership, meaning you have access to all the members, right? So let me just go like this, right? So you can see the fact that you have everything that's related to members, meaning it's from the videos, right, to the most recent post, right? Then also now how to get the PDFs, right? So under members, you're going to see the videos. Then when you go through post, that's when you're going to see my post. You're going to see post of like public, and also when it's written to members only, you now can see it, right? As you see the fact that every time when I release a video, I do say the fact that there's a PDF. So this is the PDF for the NBT past paper, right? And also this is the PDF for the master series, right? Then this is like the normal posts, right? Then do you see the fact that this is the PDF for what? This is the PDF for paper 2, May, June. And also this is the PDF for what? For paper 1, right? Okay, so now let's go to one of the posts, right? We see the fact that this is the access. Now when you click on it, right, it's going to give you like Google Drive, because it's a Google Drive. So don't worry, it's public, right? So then when you scroll down, you'll see the fact that the PDF is within two versions, right? Is that you have the actual, it tells you that which PDF it is, right? Then you're gonna have the question paper first, right? Then after having the question paper, then you're gonna have the memo. The memo is exactly how the video is, but now it's in PDF format, right? So all of them are going to be like this, where you get what? You first get the question paper, right? Then underneath it is the memo. Hope that makes sense, right? So that is how you would get access to this PDF. So now we're going to do statistics, right? So we're going to do question 1. It says the ages in years of visitors that visited the B&B the bread and breakfast, the B&B on a specific days were recorded. So this is the age. So this is the record of the age. So as we can see, they already put it in like from the smallest to the largest, right? So that's what we have. Then the first question says identify the mode. What is mode? Mode is the most common, the number that appears a lot. So it's the highest number that appears a lot. So here we see the fact that 20 is the number that appears more than any number. So that is going to be the mode, right? You see here we have 20, we have 20, here we have 20, right? So our mode here is the number that appears the most, right? So therefore we know the fact that our mode is equal to 20. So our mode is equals to 20. Hope that makes sense, Anna. So now we're going to do 1.2. It says it is further given, right, that the interquartile range of the age of the visitors is equals to 14. Then they say calculate the value of t, right? So now we are given the fact that the interquartile range, so we're given that the interquartile range, right, is equals to 14. How do we find the interquartile range? The formula for the interquartile range, right, the interquartile range is equals to Q3 minus Q1. So first we're going to be doing Q1, right? So finding Q1. So finding Q1, right? So with finding Q1, first we need to locate it, right? So we're going to be using the location formula. So it's going to be location, right? Location, right? Location of Q1, and that is equals to 1 over 4. Then open bracket is going to be n minus 1. Then it's going to be plus 1, right? So that is the location. So with that is that we need a couple of things. We need n, right? So we know that n is equals to, if you go back to your data, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we see the fact that that is going to be equals to 16, right? Our n is going to be equals to 16. So finding the location is going to be 1 over 4. Then it's going to be 16 minus 1, and it's going to be plus 1, right? Then punch that into your calculator. So you're going to get your position is going to be 4,75. And since this is a decimal, that means our position here is going to be at 4, right? It's going to be at 4 and, no, sorry, it's going to be at 4 and 5. So it's going to be at 4 and 5. Hope that makes sense, right? So we're going to take our data, right? And looking at that, we're looking for the position 4 and 5. So it's going to be 1, 2, 3, 4. So it's going to be here at 4, right? And also at 5. Then now finding Q1, right? So finding Q1 is equals to 20 plus 20, right, divided by 2. Finding the average of it, right? And we're going to find the fact that this is going to be equals to 20. So that's how you would find Q1, right? So now finding Q2. So finding Q2, right? So with finding Q2, it's going to be what? First, we need to find the location, right? So finding the location. So it's going to be the location of what? So not Q2, Q3, right? So remember the fact that it's Q3 minus Q1, right? So location of Q3 is going to be equals to 3 over 4, open bracket, n minus 1, and it's going to be plus 1. We already know that n is 16, so it's going to be this, then it's going to be 16 minus 1, then it's plus 1. Then when you take that into your calculator, right? When you take that into your calculator, you're going to have 3 divided by 4, right? Then you're going to get that your answer is going to be 12, comma what? Comma 25. Since again it's decimals, right? Is that it's going to be in 2 position again. So it's going to be at 12 and also at 13. So that's going to be your position. So now I'm just going to paste our data here, right? So it's going to be position 12 and 13. So now let's find position 12 and 13. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going to be 12, right? So it's going to be 12 and 13, right? So now finding Q3, so go up, finding Q3. So we know the fact that since it's two position, we need to find the average of it. So it's going to be Q3 is equals to 11t plus 11t plus 2. That whole thing is going to be divided by what? It's going to be divided by 2, right? So now let's clean it up, right? So let's clean it up. When we clean it up, we're going to have that Q3 is equals to 22t, right? Plus 2, and that is going to be divided by 2, which is the same as what? As having Q3 being equals to 11t plus 1, right? So that's Q3. Then remember the fact that we were given that the interquartile range is equals to Q3, right, minus Q1. But we know that the interquartile range we were given as being 14, right? Remember the fact that that is 14. So we know the fact that this is going to be 14 is equals to Q3 is going to be 11t plus 1, right? And this is going to be minus what? Minus 20, right? So this is going to be minus 20. Right? So now we know the fact that this is going to give me what? So I'm going to say 14, take the 20 to the other side. So it's going to be plus 20. And this is going to be 11. This is going to be 11t, right? Plus 1. Take the 1 to the other side. So it's going to be 14 plus 20 minus 1 is equals to 11t, right? So this whole side, the numbers is going to give me 33. So this is going to be 33. Is equals to 11t, right? So divide both sides by 11. So it's going to be 33 divided by 11 is equals to t. So therefore, we see that our t is equals to 3. So that's how you would solve this question. So now we're going to do 1.3. It says the fact that calculate the mean of the visitors, the age of the visitors, if t is equals to 3, right? So first from the table, we need to calculate 11t and this one, right? So first, let's calculate 11t. So we know the fact that 11t is the same as 11. Then it's going to be 3, which is going to give me 33, right? So this is going to be 33. So update this one. This one's going to be 33, right? Then now we need to calculate what? We need to calculate 11t plus 2, which is going to give me 11. Then it's going to be 3 plus 2, which is going to give me what? 35, right? Then let's update it. Then this is going to be 35, right? So now calculating the mean. So calculating the mean is adding all of them, right? All of them divided by the number, right? So to calculate mean is going to be x bar. X bar is equals to the sum, right? It's going to be the summation. So I'm not going to say the summation. I'm just going to add. So I'm going to say it's going to be the sum, which is going to be 15 plus 17 plus 20 plus add all of them. Then I'm going to take the last 3 again. So it's going to be 36 plus 38 plus 55. So it's adding all of them, all the values that are in this table, right? And that is going to be divided by n. Remember that our n is 16, so it's going to be 16. So we know that x bar is equals to, when you add everything that's on top, you're going to get 444. Then that is going to be divided by 16. So therefore, we find that x bar, right? We find that x bar is equals to what? Is equals to 27,75. So this is the average age, right? So hope that makes sense. So now we're going to do 1.4, which is calculating the standard deviation. Remember the fact that you're going to use this table that has the updated, right? So now calculating the standard deviation is that you need to use your calculator. So using your calculator, I'll just put a video below just to show you how to use your calculator, right? So finding the standard deviation, you're going to find that your standard deviation, right, your standard deviation, it's basically equals to what? It's equals to, it's going to be equals to 9,6. It's going to be 9,86. So that's going to be your standard deviation. So now we're going to do 1.5, right? It says how many visitors have the age that is less than 1 standard deviation. So what is the keyword? The keyword is that we're looking for less than 1 standard deviation of the mean, right? So that's what we're using. So this is the key. This is going to be the table when we're dealing with 1 standard deviation, 2 standard deviation, 3 standard deviation of the mean, right? So you need to understand the keywords. So with us is less than. So we see that less than is going to be here, meaning the calculations, we need to calculate this. Hope that makes sense, right? So we're looking for the standard deviation minus n, the standard deviation. What is n? Do you see the fact that in the equation they said 1? So n, so here we see the fact that x, so let me just increase my pen. We see the fact that here x, right, the x bar is equals to what? It's going to be equals to 27. So we know the fact that x bar is equals to 27,75. Then we know that the standard deviation, right, is equals to 9,86. Then our n is this number. They're going to tell you 1, 2, 3. That is n. So that's going to be 1, right? So we're calculating when x bar, right, minus n, the standard deviation, which is the same as 27,75, right, minus, then n is 1, then it's going to be 9,86. So when you punch this into the calculator, you're going to get it as being 17,86, right? So now looking at the data, right, you need to basically find numbers that are less than this. Remember the fact that it's less than this. So now what we're looking for, we are looking for, let me just write it here. Let me just take this and put it down. We are looking, so we are looking for ages that are less than the answer that we got, which is 17,86. Then taking this data, we see the fact that those numbers is what the numbers that are less than this is going to be here. So let me just increase my highlighter. It's going to be 15 and 17, right? So we see the fact that it's 2 ages. So our answer is going to be 2. So only 2, right? Only 2 of them are less than what? Only 2 visitors, right, are less than 17,86. So only 2 visitors. Hope that makes sense. That's how you would solve this question. So now we're going to do question 2, right? Question 2, it says, an athlete's finishing time on her daily temperature were tracked during 10 years of the Comrades Marathon to investigate the relationship between what? Between temperature and race completion time, right? Then they tell us that the table below shows the data from those 10 years. So we see the fact that that is the data, this is the temperature and the finishing time of the athletes, right? And this is the data. Then I'm going to do 2.1 and 2.3 at the same time. Because of here, we're going to be using a calculator. I'm going to put my master statistics showing you how to calculate this too using the calculator, right? So now with this one is that they say calculate the coefficient, right? So calculating the coefficient, in your calculator, you're going to get the coefficient, right? Which is the coloration coefficient is equals to 0.96, right? Then 2.3 is that calculate the equation of the least squared of the line. So we see the fact that there we need to calculate A, which we find that our A is 10,92. Then we need B, which is going to be what? 1,53, right? Then the equation is y is equals to what? Y is equals to A plus what? Plus BX. So it's going to be y is equals to 10,92 plus 1,53x. So that's how you'll basically solve 2.1 and 2.3. So now we're going to do 2.2. It says, comment on the strength of the relationship, right, between what? Between the temperature and the finishing time. So commenting on the strength, this is the strength, right? So now looking at it, so we see the fact that this is how we need to write it. So we need the strength and we need the sign. So we know that R is equals to what? Is equals to 0.6. So we know the fact that it's positive. So it's going to be fall on the positive sign. So our sign is going to be positive. So it's going to fall here. So it's going to be positive, which falls here, right? So we see the fact that it's very strong. So now commenting on it, our answer is going to be what? It's going to be very strong. So it's going to be very, very strong, positive coloration. So that's how you would comment on the strength, right? Now we're going to do 2.4. It says use the equation of the least square regression line to predict the temperature. So what is temperature, right? So we see the fact that temperature is X. So we need to basically find X, which is temperature. So let me just highlight it. So we know the fact that temperatures, right, which is X. If the athletics, right, so if the athletics takes 57 minutes, right, to finish the race, or 57 minutes to finish the race. So we know the fact that this is going to be Y, and when we go up, right, we know the fact that finishing time is Y, right? So using the least regression equation, which is this one, we're going to solve for what? We're going to solve for we're going to solve for X, because they gave us Y. So this is the equation that we're going to use. Right, they gave us what? They gave us Y. We know that Y is equals to 57. So it's going to be 57 is equals to 10,92 plus 1,53x, right? So we're going to take the 10,92 to the other side. So it's going to be 57 minus 10,92 is equals to 1,53x, right? So now we find the fact that 57 minus 10,92 is going to give you 46,08 is equals to 1,53x. Divide both sides by 1,53. So it's going to be 46,08 divided by what? Divided by 1,53 is equals to x. So punch that into the calculator. We see the fact that x is going to be equals to 30,12. But let's go up. They say the fact that we need to calculate to the nearest whole number, right? So the nearest whole number is going to be what? It's going to be x is equals to 30 what? 30 degrees. Hope that makes sense. So that's how you will solve this question. So now we're going to do 2.5. It says draw the least square regression line, right, on the grid in the special notebook. So we're gonna plot the data here first in this Cartesian, right? So we have the first one, which is going to be what? Which is going to be 41 and 72. So 41, we know the fact that 41 is going to be x. So 41 is going to be here. All right, so it's going to be here. And I'm just going to draw lines, right? So it's going to be 41 is going to be here. So let's just go back. We know that 41 is going to be here. And 72 is going to be somewhere here, right? So let me just move this a little. 41. Then 72 is going to be somewhere here. So we know the fact that the point is going to be there. Obviously with use that you're going to be using a ruler, right? So I'm going to just erase this. Then we're going to have 9 and 30. So 9 and 30. So we know the fact that 9 it's somewhere here. So it's going to be 9. So it's going to be somewhere here. Then 30 is going to be somewhere here. So it's going to be this point here. And we're just going to erase this. Then we have what? We have 30 and 66. So we have 30 and 66. So we have 30. So 30 is going to be here. And 66 is going to be somewhere here. So we see the fact that 30 and 66 is going to be this point here. Then we're going to erase this. Right, so let me just put ticks on what I've done. I've done this, I've done this, I've done this. Then we're going to have 15 and 29. So 15 is going to be this one. So it's going to be this one. And 29 is going to be here. So we know the fact that it's going to be this point here. Then we're going to just erase that. Then this is sorted. Then we're going to have 25 and 45. 25 and 45. So 25, we know the fact that it's going to be here. 25 is going to be here. Then 45 is going to be this one. Right? So it's going to be here. Then we're going to just erase that. Then we're going to have what? So this, we're going to have 20 and 43. So 20 is going to be here. 20 is going to be here. Then 43 is going to be somewhere here. Right? So we know the fact that it's going to be this point here. Then it's just going to erase this. Right? So this one is sorted. Then we're going to have 20 and 41. So it's going to be 20 and 41. So we see again that we have 20. So we know the, go back. We know the fact that, go back, 20, which is, go back. So this is going to be 20. So we know that it's 20 and 41. So 41 is going to be somewhere here. Was it 20 and 45, right? So it's going to be 20 and 41. So 41 is going to be somewhere here. So it's going to be this point here. It's going to be this point here. Here. So let's just erase this. So that covers this one. And then we're going to have 35 and 66. 35 and 66. So 30, 35 and 66. So we know the fact that it's going to be 35. So it's going to be 35. So it's going to be 35. So it's going to be 35. Right? And 66. So 66 is just somewhere just above this one. So it's going to be this one here. So that's going to be that one. Then we're going to have 39 and 68. So 39. So 39 is here. So 39 needs to be somewhere here. Right? So 39 and what? And 68. 68 needs to be somewhere here. So that's going to be somewhere here. Then we're just going to erase that. Then lastly, we're going to have 16 and 31. So 16 and 31. So 16 and 31. 16 is somewhere here. So 16 and 31. So it's going to be somewhere here. Okay, so it's going to be 16. So it's going to be somewhere here. Oh, I keep on thinking, yes, 16. It's going to be somewhere here. Then 31 is going to be somewhere here. 16 and 31 is going to be this point here. Then you're just going to erase this, right? Then now you need to draw the best fit, right? So with the best fit, you need to connect it to at least 2 points, right? So we see the fact that if I draw my line, so you're going to take your ruler, obviously. So I'm just going to draw it, draw the best fit. So it's going to have to go through 2 points. Straight line, so it's going to have to go through 2 points. So let me just adjust it so that it goes through 2 points, and that's going to be your best fit. So that's how you would basically draw your best fit line. Hope that makes sense. Huh? So now we're going to do analytical geometry. We're going to do question 3. So they tell us the fact that we have point A, B, B, and C. So they gave us the coordinate of point A. B, they didn't give us. Then C, they gave us, right? Then they tell us the fact that they also gave us the point D, right? So what do we see about point C and point D? Do you see the fact that they share the same x coordinate, meaning this line is parallel to the y-axis because of this is a straight line. Because of D and C share the same coordinate, meaning by default we know what this coordinate is. So let me just erase this. I want it in red. By default we know that this coordinate is also going to be 3:0 because it touches the x-axis. Hope that makes sense, right? Then they tell us more important information, which is what I want. It's this one. They tell me the fact that BD, which is this line, the equation to that line is y is equals to -4/3 x minus 2. So that is the equation to this line, right? So we have all the information that we need. So now I think what we can do is go answer the question. So the first question, it says calculate the length of AC. Where is AC? A is here and C is here. So this is the length that we want. The nice thing is that we know what is point A. So we know that point A, the coordinate of A is what? So let's write the coordinate of A is -3 is to -8, right? And point C, we see the fact that is what? It's 3:4. So the length is that we need to use the distance formula. So we're looking for AC, which is equals to the square root, open bracket, XA minus XC all squared plus, then it's going to be YA minus YC all squared, and this inside the square root, right? Then remember the fact that our answer, they say the fact that we need to do it in simplest form, insert form, right? So now let's substitute using this. So we know the fact that AC is equals to the square root, then this is going to be -3 minus 3 all squared, right? It's going to be -3 minus 3 all squared plus, then it's going to be -8 minus 4 all squared, put in the square root. So now when you punch that into the calculator, you're going to get that your AC, right, in simple set form is equals to 6√5. Now we're going to do 3.2. It says calculate the gradient of AC. So we're looking for the gradient of AC. And let me just do this. Take the coordinates. I'm going to need them duplicated. Cut them. And I'm just going to put them here. Yes, right? Looking for the gradient. So the gradient formula is going to be YA minus YC divided by what? Divided by XA minus XC. Remember the fact that there needs to be consistency, right? If you start with A, it needs to be A in the denominator and vice versa, right? So now let's substitute. So the gradient of AC is going to be what? It's going to be -8 minus 4, right? So it's going to be -8 minus 4. Then it's going to be -3 minus 3. So therefore our gradient, right, is going to be equals to what? It's going to be equals to 2. So we know that the gradient of AC is equals to 2. Now we're going to do 3.3, right? So go up. They say the fact that determine the equation of the line AD in terms of y, right? So go up. So the equation of AD, so we see the fact that A is this one. So we see that A is this one and D is this one. So we need the equation of this line, right? So we need what? We need to find the gradient. First, we need to find the gradient on AD. Then we need one set of coordinates to do it, right? So that's what we need to do. So let's do that. So we know the fact that the gradient of the point A, our coordinate is what? Is -3, right? Is to -8. And we know that D, let's go up, it's 3 is to -6. So it's going to be 3 is to -6. So we have that, right? So first we need the gradient. Remember the fact that we're going to use this formula, which is y minus, I'm not going to say y1, right? I'm going to use either coordinate. So I'm going to use point D. So I'm going to say y minus yd is equals to the gradient of AD, right? Then open bracket is going to be x minus xd, right? So this is what we're going to be using. Hope that makes sense, right? So let me just close the bracket like this. So here, what do we need? We need this because we already have the coordinate of D. Hope I'm making sense, right? You could have also used the coordinate of A. It really doesn't matter. Either coordinate is going to give you the same answer, right? So now we need the gradient of AD. So we need the gradient of AD. So we need the gradient of AD. So that's equals to what? To YA minus YD divided by what? Divided by XA minus XD. So let's substitute. So we know that the gradient of AD is equals to negative 8 minus 6. Then that divided by what? That divided by negative 3 minus 3, right? So we know that the gradient of AD now is going to give me positive 1 over 3, right? So now we know that that's that. So with that is that substituting here is going to be y minus what you call this dyd is negative 6 is equals to 1 over 3. So it's going to be 1 over 3. Then it's going to be x minus 3. Hope that makes sense, right? So you have that, clean that up. So it's going to be y plus 6 is equals to distribute the 1 over 3. So it's going to be 1 over 3 x minus what? Minus 3 divided by 3, right? So this is the same as y plus 6 is equals to 1 over 3 minus 1. Take the 6 to the other side. It's going to be y is equals to 1 over 3. This is x, right? X, and this is going to be minus 1 minus 6. Therefore, y is equals to 1 over 3 x minus 7, right? So we see the fact that this equation here, right, matches up with this one. What do we know? And I'm going to update it now. We know the fact that now, meaning since this is the y-intercept, right, of this line, we have the equation, we have the coordinate of this one. So now updating the equation for this one, the point of this one. Remember the fact that this 7 gives us the y-intercept, right? So meaning that point there is going to be what? It's going to be 0 is to negative 7. Right, so we have updated our diagram and also we have solved this question. So now we're going to do 3.4. It says calculate the size of the angle CKD. So this is the angle that we want, right? I'm going to just do it in red. So this is the angle that we want, right? Then how do we get that angle, right? So I'm going to do it like this. We see the fact that we have the following. So let me just show you. Is that you see the fact that this triangle, and you'll see why I'm using that triangle, is that we already know what is we can find, or we already know what the gradient of this one, and we know what the gradient of this line, right? We can find this angle, which this angle can give me this angle, right? From this triangle, right? Hope that makes sense. And we see the fact that with this line, right, with this line here, I can find this angle here. And remember the fact that with this one is that we already know what is the gradient for that one. We already solved it. They already gave us. Hope that makes sense, right? So we can find this angle here. Very important is this angle here. And we know something about this angle. Or you can find this angle. Actually, we're going to find this angle. We know this is vertically opposite with this angle. So now we know the fact that using this triangle, right, we're going to have this angle, we're going to have that angle. Sum of angles of a triangle is going to give me this angle. And that, since this is on a straight line, right, I can find the angle that they want. So that's what I'm going to be doing, right? So that's what we're going to be doing. So we're going to use this line, right? So we're going to be using this triangle. Do you see this triangle in blue? And we're going to find this angle here, and we're going to find this angle here using the tan theta to gradient properties, right? To find those two angles. Then using sum of angles in the triangle, we're going to find that. Right, so now let me just highlight. So we're gonna call this one alpha, right? Which we know the vector is going to be equals to that because that's vertically opposite. And no, this is theta, this is going to be alpha, right? We're going to find them using the 10, right? Then this is going to be vertically opposite, which is we're going to get this, right? Then from there is that using sum of angles in a triangle, we're going to find that, which now angles in a straight line, which is that. So now the train of thought, right? So first, we know the fact that angle theta, so we know that theta, so tan theta is equals to what? To gradient AC. Hope that makes sense, right? We know the fact that is equals to angle gradient AC, right? So we know the fact that angle theta is equals to, what is the gradient of AC? Remember the fact that we found that as being equals to 2. We found that gradient AC, what you call this AC, so the gradient of AC, we know the fact that that's equals to 2. We already solved it when we were solving it, right? So therefore, we know the fact that theta is equals to arctan of 2, right? So therefore, theta is equals to what? It's going to be equals to 63.43 degrees. Hope that makes sense, right? So we know the fact that this is 63.43, and therefore this is also 63. So therefore, let's name that. So okay, let's just find those angles, then we'll just name them in the triangle. Hope that makes sense, right? So we have that. Then now we know the fact that 10 alpha is equals to what? Is equals to this gradient, right? So we know that this gradient is what? It's from this equation. So we know that equation, I'm going to call it equation A, BD. So it's going to be BD. We know the fact that that is equals to negative 4. That's going to be equals to negative 4 over 3. 4 over 3 x minus 2. Right? So we know that, right? So with that said, is that we have the following, right? So we have the following. We have that the negative, right? The negative is finding the acute angle, right? So the negative is that if you wanted this angle, so basically this gradient gives us this angle. But the easiest way is that the acute angle on the other side, right, is basically just taking this positive, and you never find the angle using like substituting the negative number. Hope that makes sense, right? So since I know the fact that if I just find 10 of this angle here, right, because I'm looking for this one, is that I can just take the positive, right? Hope that makes sense. So that's what we're going to be doing, is that now alpha is just this, then gradient of the positive. So we always take, so the key is we always take the positive gradient, right? So if you wanted this one, right, it was going to be 180 minus, but we do not want that one. I'm dealing with the acute of it. Hope that makes sense, right? So gradient of BD, the positive value, which is going to be 10 alpha. This means positive, so it's going to be negative 4 over 3, which is the same as 10 alpha, right? Is equals to what? Is equals to 4 over 3. So therefore, alpha is equals to arctan, right, of 4 over 3, right? Hope that makes sense. So when you punch that into the calculator, you're going to find the fact that your angle alpha is basically equals to 53.13 degrees, right? So that's what we have. So we know the fact that this is going to be 50. It's going to be 53.13, right? So that's what we know. So that's what we have so far. Then now moving into the triangle, right? So I'm going to say, and this is going to be, you know, the gradient of BD is equals to negative 4 over 3. So let's put this inside a square. So now we're going to say in. So we're going to look at the blue triangle. So it's going to be in triangle GBD. GKF, GKF. We know the following, right? We know that angle alpha is equals to the angle, this angle, because that's vertically opposite angle. So it's going to be GFK. So that's GFK. So it's going to be GFK, right? And that's vertically opposite angles. Vertically opposite angles, right? So this is also alpha, right? Oh, theta, sorry, theta, right? So we also know that angle alpha is equals to this one, which is going to be FGK. So it's going to be angle FGK. And the reason is vertically opposite angles too. Vertically opposite angles. So now we want this one, right? We want this one. We want this angle, right? We can use it using sum of angles in a triangle. So we know the fact that that angle which is GKF. So we know the fact that angle GFK plus FGK and GKF is equals to 180 degrees, and the sum of angles in a triangle, sum of angles in triangle, right? So we know that, but we know the fact that was theta and alpha, right? So we know the fact that theta is 63. So it's 63,43 plus alpha is 53. So it's going to be 53,13, right? And the one that we want is GKF, right? So we know the fact that that is equals to 180 degrees, right? So we know the fact that that is equals to 180 degrees. So now with that said, right, now let's basically sort it out. So we know the fact that GK is equals to 180 minus 63,43 minus 53,13, right? So we know that. So now let's sort that out, right? So when you take your calculator, right? When you take your calculator and you say what? And you say 180 minus 63.43. Then you say minus again 53.13. You get that your angle GKF is equals to what? Is equals to 63,44 degrees. I'm noticing something as I'm doing this, but we're already far along, is that that is actually exterior angles of, or what? This is exterior, right? Because now is that if you say 180, right, minus this angle is going to give you the summation of this two. But we already just here, just showing you the fact that that could have been another way that you could have solved it. So therefore, we know the fact that this angle GKF plus the angle that they want, which is CKD. So CKD is equals to 180, and that's angles in a straight line. So straight line. As I said, the fact that you could have just done exterior angles of a triangle because of this angle is equals to twice this. But that's what I'm saying already, since we've went this far, we just so much just do this, right? So we know the fact that this one is 63,44, right, plus CKD is equals to 180 degrees. So therefore CKD is equals to 180 minus 63,44, right? So now with that said, is that we know the fact that our CKD is equals to what? So if you say 180, so if you say 180, so when you say 180 minus 63.44, you find that it's going to be 116.56. So now we're going to do 3.5, right? It says if it's further given, so it's further given that AC, so AC, right, is equals to 2 times K, 2 times KC, so it's 2 times KC. So if this is X, so AC, if the whole line of AC is X, so let's just make it in red. If this whole line is X, right? So if this whole line is X, then KC, where is KC? KC, so let's make this line KC. Right, so I'll go back. You see that this line KC is equals to 2x. So that's what it means, right? So we have that. But they tell us the fact that they want us to determine the area of, so the area of CK, so CKD. So this is the area. Remember the fact that when we started with the equation, I told you the fact that this line is parallel to the y-axis, right? So meaning it's straight. So meaning any line, any line that goes from the vertex, which is this is the vertex down here, it's going to create a 90 degrees, meaning that's going to create our height. So we see the fact that this is going to create our height, right? From this point K, right? Going, okay, K. From this K going down like this is going to create a 90 degrees. And that is going to be our height, right? And we see the fact that this CD is going to be our base, right? Hope that makes sense. Since we have our height and base, is that we can find the area of the triangle. So we know the fact that area of a triangle. So area of triangle CKD is equals to half base, right? So half base times height. So we need our base and we need our height, right? So the simplest one is our base. So our base is the same as this one, right? Our base is CD. Where the 90 degrees is created is where your base is, right? So your base is CD, right? So to find the base is that you can use the distance formula, but since this line is the same throughout, since this is the same coordinate, is that it's easy. You can find the distance between here to here because of this is 0, right? Then from here to here, right? And that's going to be your base. So we know the fact that the distance, right, from here to here, since this is 4, is going to be 4. So this it's going to be 4 units, right? And then from here to here, since this one ends at -6, so it's going to be +6 because distance is always positive, so it's going to be 6. So what's 4 plus 6 is going to be 10. So the whole CD is going to be equals to 10. So it's going to be equals to 4 plus 6, which is going to be equals to 10 units. Right? So now, having that sorted out, we need to find the distance from here to here. And this one is parallel to the x-axis, right? The height is parallel to the x-axis. So first we need to find what k is, right? So we need to find what k is. So let's go up. And I want to show you guys something. Remember the fact that in the equation, they told us the fact that this is the equation of this line, and k is the y-intercept. See, meaning this -2 is k coordinate. So it's going to be 0 is to -2. So we see that k, since we were given that equation, is going to be -2. So this point here is going to be what? It's going to be 0 is to -2, right? So we know the fact that this point here also, here, the point here is going to be what? It's also going to be some x value is to -2. But remember the fact that this point here shares is on this line, and this line, the x coordinate is 3, so it's going to be 3 is to -2. Hope that makes sense, right? So now what is the distance between from here? And the nice thing is that k, remember, is on the x, is on the y-intercept, right? So here we know the fact that it's 0, meaning this distance, meaning the x coordinate of this one is going to give me the height. What is here till here? Do you see the fact that it's 3? So we see that the height is 3, right? So we see that the height is 3. Because remember the fact that this is 3, from here to here is 3, and from here to here it's 3. Hope that makes sense, because here it's 3. Hope I didn't confuse anyone, right? So the height is going to be 3 units. So we have that, right? So we have that. So now since we have that, right, we can basically now calculate we can calculate what? We can calculate the area. So now we know that the area of triangle CKD is equals to a half. Our base is 10. Then it's going to be 3. So you punch that into the calculator. You find that your area is going to be equals to 15 units square. And that's how you would solve this question. So now we're going to do 3.6. It says write down the equation of CD. Since CD, remember the fact that it's this line and it's vertically, no, not vertically, it's parallel to the y-axis, right? And we see the fact that here at C and D, it shares the same x value. So meaning the equation here is just going to be, since it cuts on the x-axis and they share the same x, so the equation is going to be x is equals to that common x x value, right? X coordinate. So the equation is going to be x is equals to what? Is equals to 3. Hope that makes sense. And just to, because we're here, right? Imagine if like we had a line here at k till maybe this point. Do you see the fact that this one is that they share the same y? So this equation for this one was going to be y is equals to the common. Hope that makes sense, Anna. So now we're going to do 3.7. So it says determine the numerical value of the area of the previous triangle. So this triangle, meaning the area of triangle CK, so CKD, right, which we already found as being 15. Then the area of E, so let's highlight that. So they want the area also of E, so E is where? E, so let's find E. So E is here, so EK, so EK, EKC, C, C, D, E. So we see the fact that this is the area that they want, right? This is the area that they want. Then we see the fact that the area of this, quadrilateral that we're looking for, it's a combination of two things. It's a combination of two triangles. And I'm just going to do this. If you divide it here, we already have the area of this triangle, right? This is the area of this triangle. So to find the area of this whole quadrilateral is going to be the area of this triangle plus the area of this triangle. So since we have this one which is sorted, we just need to find the area of this one, right? So looking at that one specifically, right? So maybe let's make it in another color. So maybe let's say the area in blue, so that we know what we're dealing with, right? So if we look at the area of the one that's in blue, and I'm going to change my pen, is that we're looking for the height, right? Because this is a triangle, right? Is that wherever we need, where from the vertex going down, right, it touches 90 degrees. We see the fact that the nice thing is that this is on the what? This is on the y-axis. So from here going down, this is going to create a 90. And also this is going to be your base. Hope that makes sense, right? So with that is that we know the fact that this is going to create our what? This is going to create our height, right? Which is going to be h. Then this one is going to be your base, right? So this whole one is going to be your base, right? So that's going to be your base. Hope that makes sense, right? So now we can find the base. The base is easy. We can use the distance formula to find the base. That's easy. Then now, how do we find the height? We see the fact that, do you see the fact that here, right? Do you see the fact that here, the base, right? The base is from this x-axis, right? Meaning it's from 0 then till here, which is going to be till the point D, right? And we see the fact that the x-coordinate of D is what? Is 3, right? So the height is the x-coordinate of D, right? So the height is going to be the x-coordinate of D, so which we see the fact that that's going to be equals to 3 units, right? I'll just write it clearly when we do it here. Hope that makes sense, right? So now with that said is that we know the fact that we already have the area. So we already have that the area, we know that the area of triangle CKD is equals to, let's just make sure, is equals to 15 units per square. So it's going to be equals to 15 units squared, right? Then we know the fact that the area that we're looking for is the area of EKCD, which is made up of the area of triangle CKD, right, plus the area of the blue one, which is going to be what? KDE, right? Plus the area of the triangle KDE, KDE, right? So we already know that CKE is sorted. So now finding the area of AKED. So let's just do this, copy this, duplicate it, cut it, right? So we know the fact that this one, it's basically equals to what? Is equals to half base times height, right? So we know that the base is equals to what? The base is equals to KE, right? So the base is equals to the length KE. And now finding that length, right? We know the fact that it's going to be XK minus XE all squared. Then it's going to be plus a YK minus YE all squared, right? So that's going to be like this. Then we see the fact that XK is what? It's 0. So we know the fact that this is going to be equals to, so this is going to be equals to, both of them, this is going to be 0 minus 0 all squared, right? Then it's going to be what? Because K and E, the X coordinate is 0. Then YK, we know the fact that it's negative 2, right? And YE is minus 7 all squared, right? So that put in the square root, right? Then now we're going to clean it up, right? So we're going to clean it up. So when we clean it up, we know the fact that this is going to be equals to what? Let me just fix this. This is going to be equals to, oh, yes, this is going to be equals to, this is 0. So this is going to be the same as negative 2 plus what? Negative 2 plus 7 all squared. And this is going to be the same as the square root of what? Of 5 squared. So the square root and the 5 are going to cancel, the square root and the 2, they're going to cancel out. So your base is going to be equals to 5. Hope that makes sense, right? It's going to be equals to 5. So now, since we know the fact that that's equals to 5, we already found that the height, right? So we already know that the height is equals to what? Is equals to the x coordinate, it's equals to the x coordinate of what? Of D. And the reason for that is that, remember the fact that it's from here, from the y-axis till D. So that is why it's that. So we know that H is basically equals to 3, right? Then now finding the area. So finding the area, duplicate it, cut it. So now let me just paste it here. We know the fact that the base is equals to 5 because we found it, and the height is equals to 3, right? So the base is equals to 5 and the height is equals to 3. Therefore, the area is 7,5 units squared. But remember the fact that we're looking for the area of this one, right? We're looking for the area of this one. So now finding the area of that one. So duplicate it, cut it. Let's go down. I'm going to paste it here. We see the fact that we know that the area of CKD is equals to 15. So it's going to be 15 plus the area of KDE is equals to 7.5. So it's going to be 7.5, right? So when you say 15 plus 7.5, you're going to get 22,5 unit squared, right? So remember, but we're looking for what? We're looking for the ratio. So what we're looking for is technically the area. So therefore, the area of triangle CKD divided by the area of EKCD is equals to, we know that this is 15 and this is 22,5, right? Punch that into the calculator. You're going to see that your ratio is equals to what? It's equals to 2/3. So that's going to be your answer for this question. So now we're going to do question 4. So it says in the diagram below, then they gave us the equation of the circle, right? And they say the fact that that is the equation of the bigger circle with center B. So what I'm going to do so that we can have proper reference, we know the fact that this is the equation of the bigger circle. So we know the fact that this is the equation of the bigger circle. Then what I'm going to do is that this one, since I'm referencing it to being the equation of the bigger circle, I'm just going to do it in red like this so that we know the fact that it color coordinates to that one, right? And maybe we're going to just do this. Hope that makes sense so that we can know which one is what, right? Then they tell me the fact that the diameter ABC, right, is the diameter drawn to produce D, right? And we say that D is actually the center of the smaller circle, right? Then they tell us the fact that GD, so GD, right? So GD is the line. So we see the fact that GD is the line that is drawn, which is parallel to the y-axis. So we see the fact that this line is the y-axis, right? And we see the fact that that line, this line here, is parallel to it. Hope that makes sense, Anna. Then they tell us the fact that to the, this is parallel to the x-axis passing through D, which is the center to the smaller circle, as you can see. Then they tell us the fact that FCE, so it's FCE, so FCE, so we see the fact that FCE is a common tangent of both the circle, right? At C, so it's a common tangent to both the circle, intersecting, so it's intersecting here with the what? It's intersecting at the x and y intercept at E, right, and F respectively, meaning this is the x-axis, meaning the x-intercept of this tangent line, and this is the y-intercept for this tangent line. Then they tell us the fact that the equation of the line GC, so the one that is parallel to the x-axis, is equals to y is equals to what? Y is equals to -5. So what I'm going to do is that I'm going to change the color. I'm going to draw a line. We know that this line, right? The equation to that is basically y is equals to -5, right? So what does it mean if the equation is equals to y is equals to -5? It means the following. It means here, since this is what that point cuts on the y-axis, meaning the point here is going to be 0 is to -5, right? And also that point here, G and D share the same what? The same y point. So it's some point, some xd is to what? Is to our y is going to be -5. Hope that makes sense, right? So then they tell us the fact that A, B, C, D is a straight line, right? So they tell us the fact that so where is it? A, B, C, right? A, B, C, D. So this whole line is a straight line. Then they tell us one important thing, the fact that the length AE. So I'm just going to do it with another color. They tell us the fact that the line AE, this line here, right, is equals to what? So go back. They tell us that this line here, right, is equals to what? They tell us the fact that that is equals to 8 units. So now we're done with basically color coordinating everything. And just to keep some consistency for the green one, it's going to be this one. Then for the blue one, it's going to be that one, right? So that is all the information that we have, and we have put in everything here, right? So now let's go and answer the questions. So now we're going to do 4.1. It says determine the coordinate of B, which is the center of the larger circle. So this is the point that they want here. And how do we do that? We're going to use this, right? We're going to use this equation to basically find it, right? So the standard form, right? So this is like the express version. So we have the fact that, let me just rewrite the equation. So the equation that they gave us is x squared, right, minus 2x plus 1, right? So it's no, plus 1. So it's x squared, right, plus y squared. Then it's going to be minus 2x. Then it's going to be plus 4y. It's minus 3 is equals to 0. So that's what they gave us, right? That's the equation of the big circle. So we need to write it in the standard form, which is going to be x. So it's going to be x minus a all squared plus y minus b all squared is equals to the radius, right? Which is r squared. Where the center, which is what we're looking for, is basically equals to a is to b, right? And whatever value that we have here is the opposite side. When you take it outside, then the radius is equals to the square root of r squared. Hope that makes sense, right? So now, how do we get it into being this form? Is that we need to do completing the square. So the first thing that we need to do is that we need to group x together, everything with x together, everything with y together, then everything that doesn't have x and y, we take it to the other side. So that's what we're going to do. So we know the fact that this is going to give us what? X squared, right? Minus 2x. Then it's going to be plus y squared. Then it's going to be plus 4y. Then the 3 is going to be on the other side. So it's going to be positive 3, right? And I'm going to highlight it. Now I'm going to highlight what we need to do. So the one with the x is going to be here, right? And the one with the y is going to be this one. So what we need to do is that we're going to focus on the one that is blue, right? The one with the x. So first, when you're doing completing the square, you take the one with the coefficient. So 1 is that we make sure the fact that the coefficient of x is a positive 1. If it's not, you need to clean that up. So we see the fact that that part is sorted. So now, when that is sorted, that is positive 1, we move to the next part, which is basically taking the coefficient of x, halving it, then squaring it, right? So the coefficient of x is going to be 1 over 2, right? Then you're going to multiply it by negative 2, right? So we see the fact that when you do that, you're going to get what? You're going to get negative 1. Then you're going to take that negative 1 and you're going to square it. And this is going to be for what? This is going to be for, so this is going to be, for, like, I just want to increase my highlighter. This is going to be for the blue one. Very important. Do not like simplify it. Leave it like this because of the sign, and the number is going to make it easy for us when we create these two brackets. Hope that makes sense, right? So we're done with the blue one. Now moving to the yellow one. Again, make sure the fact that the coefficient of y squared is a positive 1. We see the fact that we have that. Then we're going to take this. You're going to take the coefficient of y. You're going to halve it the way we did with the other one. So you're going to halve it, right? So we know the fact that that is going to give us what? That is going to give us a positive 2, and you're going to say plus 2, right? Then you're going to square it. Do not do anything. Don't simplify it. Leave it like that, right? So that is going to be for what? That is going to be for the yellow one, right? Then the answer that you get here, right, is that you're going to add it here by the blue one. Then here, you're going to add it here by the yellow one. Then also, to keep it balanced, what you do to the left hand side, you do to the right hand side. You're going to add this here and this one here. Let's do that, right? So now we see the fact that we're going to have x squared. So it's going to be x squared minus 2x, right? Then it's going to be plus open bracket negative 1 all squared, right? So that's what we're going to have. Then it's going to be plus y squared plus 4y. Then it's going to be plus 2 all squared is equals to, then it's going to be 3 plus negative 1 all squared. Then it's going to be plus positive 2 all squared. And just to color coordinate, we know the fact that we added this one here and we added it here. Then the blue one, it's here and it's also here. So do you see? We took our answer and did that. Now to get the bracket, right, is that the nice thing is that for this one, for this x, you're going to take just x because it's x and this number all squared. So it's going to be minus 1 all squared. That is why I said don't simplify it, right? Then this is going to be plus, then y is going to be the same thing. It's going to be this y alone and this number plus 2. So it's going to be plus 2. Then it's going to be all squared. Then now you can simplify the number side, right? So when you simplify the number side, it's the same as 3 plus 1, right? Then this is going to be plus 4. So when you add that up together, so let's clean this part. We know the fact that this is going to be x minus 1 all squared plus y plus 2 all squared is equals to what? Is equals to 8. So therefore, the point B, which is the center, right, is going to be this number, the opposite sign, and this number, the opposite sign. So this is going to be positive 1 is to negative 2. So now we're going to do 4.2. It says determine the coordinate of A, right, the x-intercept of the larger circle. So we go back and see the fact that A is actually the x-intercept of the larger circle. And we see the fact that we're going to get 2 points because it cuts the x-intercept at 2 points. Hope that makes sense, right? So we know the fact that to find the x-intercept, right, we need to find the x-intercept, we need to let y equals to 0, right? And we already know the fact that that is for the larger circle. So we already know the fact that the equation is this one. So meaning I'm just going to copy this equation. So I'm going to just duplicate it, cut it. So taking this equation, we're going to let y equals to 0. So wherever we see y, we're going to substitute by 0. So that's what we're going to do. So it's going to be x squared plus, then it's going to be 0 squared minus 2x plus 4, then it's going to be 0, then it's going to be minus 3 is equals to 0, right? So after simplifying this, we're going to get x squared minus 2x, then it's going to be minus 3 is equal to 0. Then we're going to factorize this. So you're going to have 2 bracket, which is going to be x minus 3. Then the other bracket is going to be x plus 1 is equals to 0. So x, equating each bracket by 0, x minus 3 is going to be equals to 0, or it's going to be x plus 1 is equals to 0. Therefore, x is going to be equals to positive 3, or x is going to be equals to negative 1, right? Then we need to determine between positive 3 and negative 1, which one is A, right? So we go back. We see the fact that A is on the negative x-axis, and the other one that we do not know the point is on the positive. So the one that's negative is going to be A. So let's go down. We see the fact that meaning, therefore, xa is equals to negative 1, meaning the coordinate of A, because it's the x-intercept, is going to be negative 1, is to what? Is to 0. And that's how you would find point A. Now we're going to do 4.3. It says calculate the gradient of AB. You know the fact that we already know that we have found A as being this coordinate. Let me duplicate it, cut it, and put it here. paste it. Then B, we also found the coordinate of B being this one, so I'm gonna copy, duplicate it, and cut it and put it there. Paste it and put it here. Now using the gradient formula, we know the fact that gradient of AB is equals to what? Is equals to YA minus YB, then divided by what? By XA minus XB. Remember, consistency. If you start with A, denominator needs to be A. If you start with B, denominator needs to be B. Hope that makes sense. So now let's substitute. It's going to be what? It's going to be 0 minus 2. Then that is going to be divided by what? By -1 minus 1. Then therefore we see that the gradient is going to be equals to -1. So the gradient of AB is equals to -1. So now we're going to do 4.4. It says calculate the length of CE. So CE, I'm just going to highlight it. We see the fact that CE is this one. This is too thick. This is going to be the length, which is going to be this one in red, right? That's the length of CE that we're looking for. Then we see something. We see the fact that we can create a triangle. I just want a different color, maybe green. Okay, let's make it orange. CE is this one. And we see the fact that from that, we can create a triangle, right? Do you see the fact that using this triangle, this one, like this creates a triangle. We have this side and we can find this two, right? We can find this side, right? So we can find the length of AC, right? But first we need to find this point here, so which we're going to do, right? But we see the fact that one important thing is that this creates a right angle triangle, right? So this creates a right angle triangle. So since it's a right angle triangle, is that using Pythagoras, we can find this length. Hope that makes sense, Anna. So now the first thing is that we need to say why we're saying this is 90 degrees, right? We're gonna say it. So we know the fact that the angle A, so we know that the angle ACE is equals to 90 degrees. And the reason is that this is a tangent and this is a radius. That is a tangent, what you call this is gonna be tangent perpendicular to radius. So we know that, right? We know that's 90 degrees. Then what do we know? We know the fact that we have the point A because we found it, right? We already know the point A is -1. So we know the fact that here point A, it's -1, right? Is to 0. And we already know that point B. So we know that point B, we found it as 1 is to -2, which is 1 is to -2. But we know something. We know the fact that point A is the radius, right? What is the relationship between the radius and the diameter? Because of AC is the diameter, is that these two are equals to each other. So since we have the coordinate of this one, we can find the radius. Then we know the fact that since this is the diameter, this is 2 times the radius. Hope that makes sense, right? So we know something. We know the fact that AB is the radius. So we know that AB is the radius. So we know the fact that AB is the radius. So you're going to say AB is the radius. Is the radius. Right? And remember the fact that when we were finding the equation, right? When we were finding the equation is that we already found what the radius is. The radius is square root of 8. Hope that makes sense. So we know that the radius is the square root of 8. So therefore, we know that AB is equals to the square root of 8. So that's great, right? So now with that, we also know the fact that AC is the diameter, so AC is the diameter, right? And therefore we know the fact that the relationship, and we know the fact that diameter, so we know that the diameter is equals to what? It's equals to 2 times the radius. So meaning meaning therefore that AC is equals to 2 times AB, right? So now, since we know the fact that AC is equals to 2 times AB, and this, when you simplify it, is the same as 2 root 2, right? So we know the fact that therefore AC is basically equals to 2, open bracket, 2 times AB. So we know that AC is equals to 4 root 2. So we know the fact that that is that, right? Then now, with that said, we know the following. We know the fact that we have this as being 8 units. We have this one as being 4 root 2. Then this one is the one that's missing. So we know the fact that it's going to be the hypotenuse plus the two sides, right? So we know that the hypotenuse is the one that's opposite the square. So AE, using Pythagoras, right? So we know that AE squared is equals to what? 2 AC squared plus CE, what they want, all squared, right? We know that AE is 8, so it's going to be 8 squared is equals to what? Is equals to AC, which is going to be 4 root 2 all squared. Then it's going to be plus CE squared, right? So now we're going to take everything to one side. So it's the same as 8 squared minus 4 root 2 all squared is equals to CE squared, right? Then remember the fact that we're looking for CE all square root, right? So we're looking for EC inside the square root. So this is the same as having what? This is the same as having CE, then square root the other side. So it's going to be 8 all squared minus 4 root 2 all squared, right? Punch that into the calculator. You're going to get that CE is actually equals to 4 root 2. So now what we're going to do, we're going to do 4.5. It says determine the coordinate of D, which is this one. We see that to find the complete coordinate of D is that we need to find XD, right? So how do we find XD? Is that we see the fact that we have the following relationship, right? Is that if we find the following, right? So, and I'm going to just do this. If we find the equation of this line, do you see this line? Because it intersects here at D. If you find the equation of that line, we can substitute X, what you call this? We can substitute Y there to find XD. Because of this line and this line, it's where they meet to find to create D. Hope that makes sense, right? So what we need is that we need the equation of this line, right? So let's find the equation of AB or AC. It doesn't matter, right? We need to find the equation of this line. Then from there, we know the fact that when finding that equation, we substitute Y to being -5. We're going to find SD. Hope that makes sense, right? So if you look back, right, when we go up, I think we found the gradient. Let's go up. We already found that the gradient of AB, right, is equals to what? Is equals to -1, which is the gradient of that entire line, the line that I'm talking about. So now, since from that's 4 point what? AB from 4.3. So from 4.3, we know that the gradient of AB is equals to -1. We know that, right? So meaning we can find the equation of AB. So the equation of AB, right? We know the fact that needs to be equals to what? It needs to be equals to MABX plus C, right? So we need to do that. So, but I think the equation that I'm going to use this one, which is going to be Y minus Y, and I'm going to pick any point here. I think I'm going to pick the point A. So it's going to be YA, right? It's going to be equals to the gradient of AB. Then it's going to be X minus XA. It doesn't matter whether you pick this point or the point B. It really doesn't matter. I just picked this one, right? We know that the point here is what? It's -1, right? We know that the point here is -1 is to 0. So let's substitute. So we know the fact that Y minus Y minus 0 is equals to what? is equals to the gradient, which is -1. Then it's going to be x minus 1, close. And this is going to be y is equals to -x, and this is going to be minus, okay, cool, let's sort out this one. So this is going to be negative, open bracket, then it's going to be x plus 1. So let's clean it up. It's going to be y is equals to -x, then it's going to be -1, right? So now we know that the equation of yb, right, is equals to this one. Now, therefore, substitute what? Substitute yd, which is equals to -5, into yab, right? So we know the fact that that is going to give me what? It's going to be -5 is equals to -x minus 1, right? Take the 1 to the other side, so it's going to be -5. Then this is going to be plus 1 is equals to -x, and this is going to give me -4 is equals to -x. Drop the negative, so therefore we know that x is going to be equals to +4, right? So now the equation, what you call this, the point D, is going to be +4 is to -5, and that's how you find the coordinate of D. Hope that makes sense. So now we need to find the equation of the small circle, right, which is with the center D. But the problem is we already have A and B. So we know the fact that A and B comes from D, right? So A and B is from D. So we know from point D, which we found it as 4 is to -5, right? This basically gives us the center. This is equals to the center, right? And the center is what? Is positive A is to positive B. So what is our A here, right? Remember the fact that from outside is the opposite sign. Do you see the fact that here is negative and here is positive? Meaning our A needs to be the opposite sign. So since here it's +4, so A is going to be -4. Then B, since it's -5, is going to be +5. So we know that A and B is that, right? So we sorted with A and B. But our problem is the ratio, right? So if we look at our diagram, right, the ratio is this. It's this line that I highlighted. We already have this point. So we already have this point, right? We already have this point, which is 4 is to -5. But now how do we find this one? What do we know about the relationship between this diameter, right? This diameter and the radius. We know the fact that this point B is the midpoint, right? So we know the fact that from the line AB, point B, which is the center, is the midpoint. So we can find the coordinate of C because we have this point and this point using the midpoint theorem. Hope that makes sense, right? So we know the following. We know that point B is the midpoint of what? Of line AC, right? Which makes sense, right? Because B is the center, right? Because let me just say it, because B is the center, right? Is the center, and we know that AB, right, is equals to what? Is equals to AB is equals to half of AC. Just showing you the fact that it's genuinely the center. Hope that makes sense, Anne? And that's the center, the radius, and all that. Hope that makes sense, Anne? So now, with knowing that relationship, we know the fact that using the midpoint formula, which is going to be midpoint right, is going to be equals to, since we're finding the midpoint of this entire line and we already have the midpoint as being this point, and let me just fill in the coordinate. We know that this is -1 is to 0. This is, let's go up. What is B again? 1 is to -2. So it's going to be 1 is to -2. And we're finding point C. We know the fact that we're looking for the midpoint of AC. 1 is to -2, right? We know the fact that we're looking for the midpoint of AC, right? Which the midpoint of AC is basically equals to B, right? So we know the fact that the midpoint, we're looking for the midpoint of AC, and the formula is going to be XA plus XC divided by 2. Then it's going to be YA plus YC divided by 2, right? But we know that the midpoint of AC is basically equals to point B, right? So now let's substitute. We know the fact that point B is equals to what? Is equals to 1 is to -2. Then now let's substitute what A is. We know XA is -1 plus XC divided by 2. Then YA is equals to 0 plus YC divided by 2, right? So we have that. Then now what we're going to do is that to find the coordinate of C, is that we're going to equate X to X and B, or what you call this, X to X and Y is to Y. So we're going to equate this and this together, and this together to solve for Y, right? So that's what we're going to do. So the first one is going to be what? It's going to be 1 is equals to what? To -1 plus XC divided by 2. So now clean that up. It's going to be 1 multiplied by 2 is equals to -1 plus XC. So this is going to be 2 plus 1 is equals to XC. So we see the fact that XC is basically equals to +3. Then now you're going to move to Y. So it's going to be -2 is equals to YC divided by 2. So it's going to be -2 multiplied by 2 is equals to YC. So therefore we see that YC is basically equals to what? It's equals to -4. So we see that the coordinate of C is equals to 3 is to -4. So now we're done finding C, meaning we need to find the radius, which is r squared. The nice thing is that r squared is equals to CD squared, because this is just r, right? This CD is r, but we're looking for the square of it, so it's going to be CD squared, right? So we know the fact that CD squared is the radius. So we know that CD squared is the same as r squared. So we can find CD squared, right? That is good. We can find CD squared. So we know the fact that CD squared is equals to the distance formula without the square root. So it's going to be what? It's going to be XC minus XD all squared, right? Plus YC minus YD all squared, right? So we know the fact that X is going to be 3 minus, then maybe let me just bring my D down. So we know that D is basically equals to 4 is to -5, right? So we know the fact that that is going to be -4 all squared plus this is going to be -4 minus -5 all squared. So let's clean this up. It's going to be what? So here we're going to get it as 1 squared. So it's going to be -1, right? Then this side is going to be plus, then this is going to give me -4 plus 5 all squared. Then therefore this is going to give me what? So let's clean that up. We're going to find the fact that when you pass this into the calculator, you're going to get it as being 2. So we know the fact that CD squared is going to be equals to positive 2. So now updating the form, or what you call this, updating the circle, right? The equation of the circle, we know the fact that it's going to be x minus a all squared plus x minus b all squared is equals to r squared, right? So we know the fact that this is therefore equals to r squared. So now we're going to go back. We know the fact that a and b is equals to this. So I'm going to just duplicate it, cut it. So we know the fact that a is equals to negative 4. So it's going to be x minus 4 all squared plus, then it's going to be y plus 5 all squared is equals to 2. And this is the equation of the small circle. Hope that makes sense. So now we're going to do trigonometry. We're going to do question 5. So it says, given that tan theta is equals to negative 5 over 4, where the angle theta is between 90 and 270. They say with an aid of a diagram and without using a calculator, determine the values. So before we do that, let's fill in the diagram, right? So we're going to have a Cartesian plane. So we're going to first have a Cartesian plane. So this is going to be a Cartesian plane. And they tell us the fact that theta, right? They tell us that tan theta is equals to negative 5 over 4. So we know the fact that this is all students take coffee, right? Meaning we need to determine where 10 is negative. So we see that 10 is negative in the second and fourth quadrant, right? So we see the fact that it's in the second and fourth quadrant. So let's put ticks there. So this is for when 10 is negative. But when drawing the triangle, it shouldn't be in the triangle shouldn't be in 2 quadrant, so we need to reduce it, right? So we have another restriction, which is theta needs to be between 90 and 270. So we know the fact that this is 0, this is 90, right? This is 180 degrees, and this is 270, and this is what? This is going to be 360. So now, since the second restriction says the fact that it needs to be between 90 and 270, meaning the two options is what? I'm going to do it in red, is this one and this one. But we know the fact that here, it's what is positive. So meaning our triangle is going to be here. So our triangle is going to be in the second quadrant because it... Okay, let me just go back because it satisfies both conditions, right? That's where it has a tick and a cross. So let's draw the Cartesian, the triangle this side. Very important is that when drawing the line going down, it needs to go down and the x-axis not on the y, right? So we're going to just drop it down here. And this is going to be our triangle, our right angle triangle. And we see the fact that the angle theta is going to be always the angle between this and the x-axis. So this is going to be theta, which is going to be here, right? Then now we need to fill in the triangle. The triangle needs to be completely filled. So we know the fact that this is tan theta is what? It's opposite, right? So it's opposite over hypotenuse. Sorry, it's opposite over adjacent, right? So we see the fact that opposite of the angle is this one. So this is going to be opposite. So this is going to be 5, right? And adjacent is going to be down here, meaning this is going to be 4, right? But we see the fact that 4 is on the negative, what is on the negative x-axis. So this is going to be negative. So looking at this, right, we see the fact that we do not have r, which is the hypotenuse. So we do not have r, which is the hypotenuse, right? So now to find r is that we're going to use this formula, which is r squared is equals to x squared plus y squared, right? We have x and y, right? So we have x and y, right? X is going to be the one on the x-axis. Then y is going to be the one that's parallel to the y-axis, right? So let's fill in. So we know the fact that this is going to be r squared is equals to, then this is going to be what? This is going to be negative 4 squared plus this is going to be 5 squared, right? So now let's simplify this. This is going to be r squared is equals to what? Is equals to 16 plus 25, right? Which is going to be r squared is basically equals to 41, right? R is always positive. R is going to be always positive. So it's going to be R is equals to the square root right, of 41. So to get rid of the square is that we square root both sides. So I didn't just square root both sides, I just squared the other side only, right? So we see that r is equals to what? Is equals to positive root 41. Hope that makes sense, right? So now since our diagram is complete, now we can answer the questions, Anna. So now answering the first question, it says it wants cos theta, right? So it says it wants cos theta. So we're going to use the diagram. Cos is what? Cos is adjacent, meaning it's going to be adjacent over hypotenuse, which is going to be this one. So it's going to be negative 4 divided by what? It's going to be negative 4 divided by root 41. So we know that cos, right, is equals to what? Is equals to adjacent over hypotenuse, which this is going to be equals to what? To negative 4, which is adjacent over hypotenuse, which is going to be root 41. So that's going to be what? That's going to be our cos. So now we're going to do 5.1.2. It says we need to find 2. So let me just 2 sine squared theta. So what I'm going to do is that I'm going to take out the square outside, right? So this is going to be the same as what? As 2 open bracket sine theta all squared. This and this is exactly the same thing, right? So we already know we can use like a diagram to find sine, right? So sine theta, which is going to be opposite over hypotenuse. So it's going to be 5 divided by what? By root 41. So we know the fact that sine, what you call the sine theta, right? We know the fact that we know that sine theta is opposite over hypotenuse all squared. So this is going to be the same as 2. What did we say that opposite is? Opposite is 5. So it's going to be 5, right, divided by root 41, right, all squared, right? Then we know the following. We know the fact that we need to distribute the 2. So it's going to be 2 the square. So it's going to be 5 squared divided by root 41 all squared, right? We know the fact that 5 squared is 25. So it's going to be 2, then this is going to be 25. Then the square root here and this one are going to cancel each other. So it's going to be 41, right? So we know the fact that we're going to multiply numerator to numerator, meaning 2 multiplied by 25, which is going to give me 50. So it's going to be equals to 50 divided by 41. And that's how you would answer this question. So now we're going to do 5.1.3. So we see the fact that they want us to find cos open bracket 90 minus 2 theta. This is reduction, right? So using the reduction diagram, which is this one, right? So we know the fact that 2 theta in our diagram is going to be replaced by theta. So we're looking for 90 minus. So 90, what you call this, cos 90 minus 2 theta. So this is going to be this one. Let me just highlight it. We know the fact that we're looking for 90 minus. So it's going to be this. Go back. So let's make it small. It's going to be looking for this one, right? We know the fact that cos, what you call this, 90 minus theta becomes positive sine theta. So in our case, it's going to be what? It's going to be cos. So it's going to be cos 90 minus 2 theta, right? It's going to be equals to sine 2 theta, right? And we know the fact that sine 2 theta is an identity, right? So that the identity for sine 2 theta is basically equals to 2 sine theta multiplied by cos theta. And we're going to put that into a square bracket, right? And we're going to make it red. So we know the fact that that is that identity. So we know the fact that that is going to be equals to what? So now we're going to replace that into 2 sine theta multiplied by cos theta, right? So we know the fact that sine theta, remember we already found it, right? Sine theta is basically equals to this one. This is sine theta, which is 5, right? So which is 5. So it's going to be 2, which is 5 divided by negative, what you call the square root 41, right? So that is sine theta, right? Then cos theta was the first one that we found, which is negative 4, right? So that is negative 4 root 41, right? Hope that makes sense. So now let's clean this up, right? So I'm going to multiply numerator throughout. So numerator is going to be 2, right, multiplied by 5 multiplied by 4, and that is going to give me what? That is going to give me negative 40, right? Then when you say square root of 41 multiplied by square root of 41, the square roots are going to cancel out, so it's going to be equals to 41. So that is going to be how you answer this question. Hope that makes sense on it. So now we're going to do 5.2, right? It says prove that this side is equals to this side. So when you're proving that each sides are equal to each other, you take the most complex side. In our case, it's the left hand side, right? And this is going to be the right hand side, right? So we're going to take the left hand side and try to simplify it so that it looks exactly like the right hand side, right? So we know the fact that this is the left hand side and this is the right hand side. So taking the left hand side, so I'm going to say left hand side, right, is going to be equals to 3 cos 2x, right, plus 3 cos squared x plus 9 sine squared x, and that whole thing, right, is divided by 4 minus 4 sine squared x, right? So what I like doing is that if you look at it, right, is that we have this, which is going to give us an identity. But the problem about cos 2x is that it has 3 options, right? And since it has 3 options, when reducing, it's kind of hard to pick which one is the best one. So what I like doing is that applying other identities, then at the end applying this one so they can get closer to the right hand side, right? So what I'm going to do is that I'm going to take the denominator. We see the fact that the denominator is 4 minus, let's start simplifying the denominator, right? It's going to be 4 minus 4 sine square x, right? And that if we take 4 as a common factor, so we're going to have 4 open bracket, it's going to be 1 minus sine squared x, right? So that is that. We see the fact that this is from an identity, and I'm just going to do the identity on the side, right? So we know the fact that sine squared x plus cos squared x is equals to 1. Take the cos to the other side, right? Okay, take the sine to the other side. We know that cos squared x is equals to 1 minus what? 1 minus sine squared x. Do you see the fact that this and this is exactly the same? And the nice thing about this, do you see the fact that here in the denominator is in terms of what? It's in terms of cos. So I'm going to replace this whole thing here by cos, right? Hope that makes sense. So let's put this inside a block, just like this. Then we're going to replace that, right? So we know the fact that this is basically equals to what? To 4 open bracket, it's going to be cos squared x, right? So we see the fact that we're getting closer to what we want. Hope that makes sense, right? So now that's going to be what? So we know the fact that now the left hand side is going to be what? It's going to be equals to, and maybe let's have some consistency. The working out will make it in blue. Yes, we'll make it in blue, right? So we know the fact that that is basically equals to what? The left hand side is equals to 3 cos 2x plus 3 cos squared x plus 9 sine squared x, right? And that is divided by what? And that's going to be divided by 4 cos squared x. Hope that makes sense, right? Now we see the fact that the denominator has what we want. The only thing is the number that's in front of it. So we can sort it out, right? So we see the fact that the numerator is just a number, right? So looking at this is that we need to get rid of this the sine and this cos, right? So now what we're going to do is that I'm going to write all 3 identities of what? I'm going to write all 3 identities of cos 2x. So now we have the 3 identities, right? We see the fact that from the numerator we need 3 alone. So looking at these 3 options, right? If we need to cancel certain things, right? We see the fact that we can use this one because of it has the sine and it has the cos. And maybe if applying it, it's going to make us cancel this too. Hope that makes sense. And it's like back to being just a number. Hope I'm making sense. So that is why I'm going to apply this one instead of this two, right? So that's what I'm going to do. So we know the fact that now the left hand side. So we know that the left hand side is equals to, now it's going to be what? So it's going to be 3, right? Then open bracket is going to be cos squared x, right? Then it's going to be minus sine squared x, then close bracket, and it's going to be, let's just do it as working out. Let me just do it like this. I'm going to take the entire numerator. So it's going to be 3 cos. So what I want is 3. Then it's going to be cos squared x, right? Then this is going to be minus. So remember it's minus. So it's going to be minus sine squared x, right? Then it's going to close bracket. Then it's going to be plus 3 cos squared x plus 9 sine squared x. So now let's simplify this. So when we simplify it, we find the fact that we're going to distribute the 3. So it's going to be 3 cos squared x minus 3 sine squared x. Then this is going to be plus 3 cos squared x. And this is going to be plus 9 sine squared x, right? Then we see the following. We see the fact that we can group like terms. So I'm going to highlight it, right? We know the fact that these two are going to be together. So this and this are together. Then lastly, we see the fact that this and this is together, right? So we know the fact that the 2 is going to be 3 plus 3 is going to give me 6. So it's going to be 6 cos squared x, right? Then minus 3, plus 9 is going to give me plus another 6. So it's going to be plus, plus 6 sine squared x. Then we see we can take out what? We can take out 6 as a common factor. So it's going to be 6, open bracket, is going to be cos squared x plus sine squared x. We see the fact that that is an actual identity that is equals to this identity, right? So this is 1. So we see the fact that this is going to be basically equals to 1, which is going to be equals to 6. So the entire numerator is basically equals to 6. So let's put this into blue. Yes, so this is going to be blue. So we know the fact that the entire numerator is now equals to 6, right? So now let's substitute. So when we substitute it, we know the fact that now the left-hand side is equals to 6 divided by what? Divided by 4 cos squared x. Then we can simplify. When you say 6 divided by 4, it's going to give you what? It's going to give you 3 divided by 2. So this is going to be equals to 3 divided by 2, right? Cos squared x. And that is exactly your right-hand side. So that is exactly your right-hand side. And we have proven this question. So now we're going to do 5.3. It says simplify without the use of a calculator, and they give you the expression, right? So we see the fact that reduction is going to be here and here only, right? So we're going to start applying reduction there. So the first one is cos 90 minus x. So we see the fact that it's going to be this one. So when we come, we know the fact that it's going to be this one, right? So we know the fact that it's going to be positive sine theta, which is theta is going to be replaced by x, right? So we know the fact that taking cos, so when you say cos 90 minus x, and this is going to give you positive sine x, right? So we know the fact that that is sorted. So I'm just going to highlight it in red so that we know the fact that it's applying to which one. So we know the fact that also in here we're color coordinating everything. Then the second one is going to be this one, which is going to be this one here, right? So go back. So let me just reduce my highlighter. We know the fact that it's going to be this one, right? We know the fact that sine of a negative angle is negative sine theta. So meaning we know the fact that sine, open bracket, negative x is going to be basically equals to negative sine x. And we know the fact that that is going to be yellow. So we know the fact that this is going to be yellow. Hope that makes sense, right? Then we're going to put it back into the into the whole expression. So we know the fact that cos x multiplied by, we're going to replace that one, which is going to be sine x. Then it's going to be sine, open bracket, 48 minus x plus sine squared x multiplied by cos 48 minus x, right? And that whole thing is going to be divided by, this is going to be negative sine x. Then this is going to be cos 24 multiplied by cos 66, right? Then now looking at it, we know that we see the fact that sine is a common factor to both, right? Do you see the fact that sine is a common factor? So I'm going to take out sine as a common factor, right? So we see the fact that here sine x and we have another sine x here is a common factor. That's the thing that we can do in numerator. And the denominator, I'm just going to leave it the way it is. And I know something, if I take out sine here as a common factor, is that I can cancel it with the sine, with this sign, right? So let's do that. So we know the fact that this is going to be equals to, when you say sine x, open bracket, you're going to be left with cos x multiplied by sine 48 minus x. Then it's going to be plus. Then you're going to be left with 1 sine x multiplied by cos. Then this is going to be 48 minus x, right? Close bracket. And that whole thing is going to be divided by what? It's going to be divided by negative sine x multiplied by cos 24 multiplied by cos 66, right? So we see the fact that these two are going to cancel out, right? So when they cancel out, you're going to be left with cos x multiplied by sine. Then it's going to be 48 minus x. Then this is going to be plus sine x. And this is going to be multiplied by cos 48 minus x. And that whole thing is going to be divided by what? By, so this cancels out, so the negative still stays. So it's going to be minus cos 24 multiplied by cos 66. Then now looking at the numerator, right, which is this one, you see the fact that this identity applies. And I'm just going to color coordinate it, right? So for A, if you look at it, right, because of it's the expansion of it, right, is that for A, we see that A is represented by X, right? And we see that B, right, is represented by this one, right? And here we see the fact that they just like, it's just interchanged, but because of its multiplication, they can be seated in different positions. And same applies. We see the fact that if we have a what, if you have a cos x here, we need to match it up. We need to have a sine x, and we do have that, right? And do you see the fact that he has sine and he has cos and the same thing? So we see the fact that even here, this is going to be our A, and this is going to be our B, right? So now we can basically rewrite this in this form, meaning rewrite it in this form, right? So now rewriting it in that form, let me just go up. We see the following. We see that this can be written as, so let me just write it. Let me just take it here and write it down there, duplicate it, then cut it. So we see that this can be written in this form, right? So this can be written as what? As sine, right? Then A is going to be x, so it's going to be x, right? X plus, so it's going to be x plus, then it's going to be 48 minus x, right? So we see the fact that that is basically writing it in this form. Hope that makes sense, right? So we're going to put this into a blue block, then we're going to put it back into the expression. So we know the fact that this is going to be the blue block, so it's going to be, when we continue simplifying it, so it's going to be equals to sine, and this is going to be x plus 48 minus x, and that whole thing is going to be divided by what? By minus cos 24, right, multiplied by cos 66. So here we know the fact that it's going to be sine, then it's going to be what? It's going to be 48 divided by negative sine, negative cos 24 multiplied by cos 66. Then looking at the denominator, we see the fact that 24 can be 2 times. If you say 2 multiplied by 24, you get 48. So this one, I think we can do something to sort it out, but the problem is this one. But we have another cool thing, right? So the other cool thing is that 90, if you say 90, right? 90 minus what? 90 minus 24, you're going to get 66. So if you say 90 minus 24, right, you're going to get what? You're going to get 66. How is this cool? This is cool because I know the fact that I can replace my 66 by 90 minus, right? Which this is a co-function, right? So I know the fact that I can replace cos 66 and now it can be cos 90 minus 24. And I know the fact that 90 minus 24 is a co-function, right? Which is going to be equals to what? Which is going to be equals to sine 24, right? Which now everything is going to be in 24, which is good, right? So now we know the fact that that is that. So we're going to put this inside a square bracket. So this is going to be, now we're going to have the denominator as being equals to what? We know the fact that it's sine 48. Then that is going to be divided by what? Divided by negative cos what? Negative cos 24 multiplied by now sine 24, right? Then we see something. There's an identity, right? This identity is the same as what? Then from this identity, do you remember the fact that from this identity, which is going to be sine, so sine 2 theta is the same as 2 sine theta, right, multiplied by cos theta. We have it again if, let's say, you are given sine theta multiplied by cos theta. This is the same as a half sine 2 theta. So now we can rewrite this as this, but remember that our theta is what? Is 24. So now let's put this inside a block. So you know the fact that that identity exists. So we're gonna replace this whole thing by this because it's the same thing, right? Do you see the fact that it's the same thing, right? So we know the fact that this is basically going to be equals to sine 48. Then this is going to be divided. I'm going to take out the negative. Then you're going to have a half sine. Remember the fact that's going to be 2 multiplied by 24 because that's our theta, right? And close bracket, right? Simplify that. So this is going to be sine 48, and this is going to be minus 1 over 2. Then it's going to be sine 48. So the sine 48 are going to cancel out. So you're going to have what? You're going to have left with 1 divided by negative 1 over 2, which now is going to be what? 1 divided by negative 1 over 2, which is going to give me 1 multiplied by minus 2, which is going to be equals to negative 2. So now your answer for this question is going to be equals to negative 2. Hope that makes sense, Anna. So now we're going to do 5.4. It says given, and they give you this. Then they say the first one, simplify to a single trig ratio. So we see the fact that here, this is actually an identity, and here's the identity that we're going to use. So first, let me write the equation. We see the fact that we have cos, then it's 60 minus x plus, then it's cos 60 plus x, right? And inside the square bracket, and it's all squared. We see the fact that this is the identity that we're going to be using. So this is the one that we're going to be using, right? So for the negative one, we're going to apply it here. Then the positive one, we're going to apply it here. So let's do them separately, right? So we know the fact that the cos 60 minus x is going to be equals to what? So it's going to be cos 60, right, multiplied by cos x plus, then it's going to be sine 60, then multiplied by sine x, right? Then now let's do for the positive one, which is 60 plus x is going to be equals to cos 60 multiplied by cos x, then it's going to be minus, and it's going to be minus sine 60 multiplied by sine x, right? So now we know the fact that we have simplified this, put that inside a box. Then now let's apply it back, right? So we know the fact that that is going to be equals to what? That is going to be basically equals to, let's add them. So it's going to be cos 60 multiplied by cos x plus sine 60 multiplied by sine x, right? Then yes, so that then it's going to be plus, now we're going to put that inside a square, inside a bracket, which is going to be cos 6t multiplied by what? Multiplied by cos x minus, then it's going to be sine 6t multiplied by sine x, then square bracket. So now inside the bracket, let's group like terms, right? So we see the fact that we have the following, and I'm going to highlight, right? So we see the fact that we have this, right, that looks like this. Do you see that? Then we see the fact that blue one, we see the fact that this, right, is closely related to this, right? We see that this two, do you see, is the same thing but different signs. So this one's going to cancel out. So that two are going to cancel out because it's going to give us 0. Then this two, you're going to add them together, meaning it's two of them. So this is going to be the same as what? As 2 cos 6t multiplied by cos x all squared. Hope that makes sense, right? Then we know that cos 6t is what? Is a special triangle, which is going to be equals to a half. So we know the fact that cos 6t is equals to a half, right? So we know that, and that I'm going to put in a blue triangle. So now simplifying it, we know the fact that this is going to be square bracket 2. Then now cos 6t is going to be replaced by half. So it's going to be a half. Then it's going to be cos x all squared, right? So 2 multiplied by half is going to give you 1. So this is going to be the same as what? As cos x all squared. So your final answer is basically cos squared x. So that's how you would solve this question into a single trig ratio. Hope that makes sense, Anna. So now we're going to do 5.4.2. They said hence otherwise determine the general solution. What is our hence? Hence is we need to use the previous. So our hence in our case is that hence is the following. We know the fact that the square, right, this cos 6t minus x, right, plus cos 6t plus x, right, all squared. We know the fact that from solving it is equals to this, right? We simplified it to that. So that is our hence. We know the fact that that is already equals to that. So this is our hence, and I'm going to put it inside a square bracket, which is I'm going to put it in red. That's our hence. So we know the fact that we can replace this whole thing by this now. So we know the fact that that is basically equals to cos squared x, which is equals to 3 over 4, right? And we need to solve the general solution of this now. So solving that is that we need to get rid of the square. So this is the same as the square root of what? Of cos squared x is equals to the square root. And this is going to be plus or minus. Then this is going to be 3 over 4, meaning cos x is equals to plus or minus square root of 3 over 4. So this is the same as having cos x is equals to positive 3 over 4, or cos x is equals to negative square root 3 over 4. Then now we're going to find the general solution for this one and the general solution for this one, right? So for this one, so for cos x is equals to the positive 3 over 4, right? We need to find the reference angle. So the reference angle is basically equals to what? It's equals to arc cos of this, and that's the positive value of it. So it's going to be what? It's going to be arc cos of square root of 3 over 4, right? Then we see the fact that when you punch that into the calculator, you're going to get that your reference angle is equals to what? Is equals to 30. So we see the fact that our reference angle is going to be equals to 30. So now since we have our reference angle, we're going to check where cos is positive. So here we see the fact that there's a positive value. So we see that cos is positive in the first and the fourth quadrant. So I'm going to put the ticks there. So we know the fact that it's in the first and the fourth quadrant, right? So meaning it's going to be the reference angle plus then K316. Then the other one is going to be negative the reference angle, or it's going to be this one. So I'm going to use negative the reference angle. So we know the fact that in quadrant in quadrant 1, right? We know the fact that x, remember the fact that here this is just x, so it's going to be x is equals to the reference angle, which is going to be 30 degrees plus k 360, right? Then it's going to be again on the fourth quadrant, so quadrant 4, which is going to be x is equals to negative the reference, so it's going to be negative 30 degrees, right? And this is going to be plus k 360. So that is going to be for this one, right? This is going to be this one. Now moving for cos x is equals to negative square root of 3 over 4, right? We need the reference angle. So we see the fact that the reference angle is going to be equals to exactly this one. Why? Is because of when looking for the reference angle, we do not include the negative sign. So we see that the reference angle for this one is still going to be a cos of square root, the positive square root of 3 over 4. And we see the fact that this is going to give me 30 degrees, right? And maybe let's color coordinate this so that it makes sense. So we know the fact that for this one, okay, cool. So let me just do this. So we know the fact that for this one is going to be, I'm going to just label the text like this, right? Then for where cos is negative, right, it's going to be for this one. So we know the fact that cos is negative here and here, right? So that's where it's negative. So it's going to be in red. So I'm just going to do this in red, and this is going to be for this one. Hope that makes sense, right? So now we know the fact that in the second quadrant is 180. So it's going to be the second quadrant. So quadrant 2, we know the fact that x is going to be equals to what? Is equals to, and this is going to be 180. So it's going to be 180 minus the reference angle. So it's going to be 180 minus 30. That's going to be plus k 360, right? So solve this. It's going to be x is equals to 150 plus k 360, right? Then we know the fact that it's in quadrant 3, so it's going to be in quadrant 3. So it's going to be quadrant 3, right? Which is going to be what? 180 plus. So it's going to be x is equals to 180 plus 30 degrees. That's going to be plus k 360. Solve that. So it's going to be equals to what? It's going to be equals to 210, right? And this is going to be plus k 360, right? So now when you're done having all 4 of them, so I'm going to highlight them in green, your final solution. So this is going to be your solution, this is going to be a solution, this is going to be a solution, this is going to be a solution. And very important, don't forget to say that when k is an element of integers. And that's how you would solve this question. So now we're going to do question 6. It says sketch below is graph, then they give you the graph, which you see the fact that it's cos x minus 1 over 2. Then they say the fact that it's within this interval, meaning you see the fact that it starts here and ends here. Then the first question, it says determine the range of f of x plus 1. So first of all is that how I'm going to do this, I'm going to first find the range of f of x, right? Then after finding the range of f of x, we know the fact that this affects the range. Then we're going to add 1 by the range of this one. Hope that makes sense, right? So we know the fact that to find the range, this is what we're going to use. So let me unzoom this, right? So we know the fact that this is what we're going to use, right? So finding, so the first thing is finding the range of f of x, right? So we know the fact that the range is equals to what? It's going to be y, then it's an element, then it's going to be minus the absolute of a plus q, then it's going to be a absolute of a plus q, right? So that's what the formula says, right? So we need a, so we see that a is equals to, let's go to f of x. So we see that a is the coefficient of the cos. We see the fact that this is positive 1, right? So we see that a is positive 1. So we see that our a is equals to positive 1. Then we see that q is the one that's outside, right? So it's going to be, do you see the fact that it's the trig ratio, then plus this is our q. So we see the fact that that's negative. a half. So that's going to be negative a half. So let's substitute. So it's going to be y is an element, then it's going to be minus the absolute of 1. Then q is negative, so it's going to be minus a half. Then it's going to be 1 minus again, sorry. Okay, cool. It's going to be 1 minus again. Q is minus a half, so it's going to be minus 1 over 2, right? Then close it, then clean it up. So absolute of any number means the fact that that number is positive is always going to be positive. So this is going to be y. Y is an element, then this is going to be minus 1 over 2. Then this one is going to be 1 minus 1 over 2. Hope that makes sense, right? So now we're going to clean up this, right? So when you say minus 1, so when you add these two together, you're going to find that y is an element from negative 3 over 2, right? And when you say negative 1, right? So when you say negative 1, positive 1, sorry. So when you say positive 1 minus a half, that's going to be positive a half. So this is going to be positive a half. But this is the range of f of x. So now finding the range of now f of x plus 1, what they want, right? Plus 1. So what you're going to do is that you're going to take this one, just add plus 1 here and plus 1 here. Hope that makes sense, right? So we know that the range is going to be y is an element. Then this is going to be negative 3 over 2. Then you're going to say plus 1, and let's highlight it. We know the fact that this is the plus 1 that we're adding. And then same applies. It's going to be 1 over 2. Then it's going to be plus 1. So again, we're just adding plus 1. Right? So that's what we're going to do. Therefore, the range is going to be what? It's going to be negative. So when you go to your calculator, and say minus, then you're going to say 3 over 2, right? So when you say 3 over 2, then you're going to say plus 1. You're going to get that as negative a half. Then when you say a half, so when you say 0.5, which is a half, plus 1, you're going to get the fact that that is going to be positive what? Positive 3 over 2. And that is the range for this one. Hope that makes sense, Anne? So that's how you would solve this question. So now we're going to do 6.2. They say in the same set of x's, sketch the graph, and this is the graph, right? G of x, and they say the interval needs to start here and ends here. Then they say the fact that we need to use, but on the grid provided, the special answer book clearly indicate the x-axis and the the intercepts with the x-axis. So we know the fact that I'm going to use the calculator to sketch this, but in the calculator, I know where it starts, I know where it ends, but very important, I need to know the interval. So the interval, if you look at the diagram that they gave you, you see the fact that your interval is from 0 to 30, and it keeps on increasing by 30. So your interval is going to be 30, and it's because of this grid. Hope that makes sense, Anne? So now using your calculator, I'm going to show you on how to sketch this. So now we're going to do g of x in the calculator. So the first thing you're going to say mode, then you're going to look for something that says table. In my case, it's 7. So I'm going to say 7. Then I'm going to put in my sign. So it's going to be sine, right? Sine, then it's going to be alpha. Then it's going to be x, right? Then it's going to be plus 60. Then close, and we're going to say equals to. We do not have a second graph, so this is basically equals to. Then where are we starting? We're starting at negative 120, and we're going to be ending at 240. Then steps. Remember when I did the interval on the graph? So we know the fact that our intervals are 30 because that's what we've been adding to get our next value. So it's going to be intervals of 30. And this is going to be how it's going to look, our table. And we're just going to copy and paste this table. And we're going to just sketch this graph. So now here's the table, right? So what I'm going to do is that I'm going to mark off this one. Negative 8.66 and positive 8.66 because I see it recurring. So I'm just going to do that. So I know the fact that negative 8.66 needs to be somewhere here. and positive 8.66 needs to be, do you see this is 1? So it needs to be somewhere here, right? I'm gonna mark it off in dotted lines so that I know where it is. So I'm just gonna take solid dotted, and I'm gonna just move it into red. So in positive 8.66, I'm just gonna draw a line coming like this. Then for the negative side, it's gonna be this one, and it's just gonna help us sketch it properly, right? And I'm just gonna move back to solid, and we know the fact that this is what? This is positive, right? 0.866, and this is negative 0.866. This is negative, right? So we have that, right? Then 0.5, we know the fact that it's going to be here, between here, and the positive one's going to be this one, right? So now let's start sketching it. So we know the fact that 120, so now put in dotted lines, right? I'm going to do it in green. We know that 120 is negative a half, so it's going to be here. Then we know the fact that negative 90 is negative 8.66, so it's going to be here, right? Then we know negative 60 is going to be positive, it's going to be negative a half, so it's going to be here, right? Negative 1, sorry. Then it's going to be 30, it's going to be negative 8.66, is just this one. Then it's going to be what you call the 0 is going to be what? It's going to be here, which is going to be negative a half. Then it goes up, so we know that the 30 is going to be 0. It's going to be like this. Then it's going to be 60, it's positive a half. Then we know the fact that 90 is here, right? Then 120 is going to be here. Then you see the fact that it's going to create a pattern. This is how it's going to be. Yeah, then it's going to be here. Yes, so we have that, right? So now what we're going to do is that we're going to connect the dots. So it's going to be like this. So let me just erase this. Yes, so let me just draw it properly. So we know the fact that's going to go like this, then like this, it curves, then it's going to be like this. There's two connecting just like that. That's going to be just like that. So that's going to be your what? That's going to be your g of x. So now they say write down the values of x for which g of x has a minimum value. So we're going to look at g of x, right? So we see the fact that g of x is equals to sine. And then let's go up. Then it's x plus 30 degrees. So it's going to be x plus 30 degrees, right? So what I'm going to look at, I'm just going to ignore this 30 degrees and look at where is the minimum value for sine x, right? So we know the fact that sine x, so if I had to draw the graph, and you can, I'll just show you. If I had to draw a graph, and this is the graph, right? Then I'm just going to be from 360 to negative 360 till positive 360, no? So I know the fact that this, let me just take my ruler so that everything can be sorted. So let's say this is 90, right? This is 180 to 70. I think that's a lot. So this is 90, this is a 180, then this is 270, then this is 360. So it's the same thing this side, 1, 2, 3, 4, right? So let's hide it. So we know the fact that our graph goes like this. So the turning point is going to be here, then it cuts here, then the turning point is going to be, so cuts here, then the turning point is going to be here, then cuts here, right? So it's going to be like this. Right? So this is what, remember the fact that I'll just mark it. Wait, then this is going to be the turning point here, cuts here, turning point here, then cuts here. So it's going to be like this. I'm just going to rechoose my pen so that we can mark it. And we know the fact that this is 90, this is 180, 270, and this is 360. Then this is 0, negative 90, negative 180. Then this is negative 270, and this is going to be negative 360. Then we know the fact that here and here, this is going to be negative 1, and this is going to be positive 1. The minimum value is where it creates a smiley face. That's the minimum value, right? So we see the fact that where it creates the minimum value, it's going to be here. So it's going to be here. So let me just draw the line. That's where it's going to create the minimum value. It's going to be here, right? It's going to be here, and it's also going to be here, right? And that x value for that is going to be at 90, right? And the other one is going to be at 270. And this is very important, right? So this is going to be, this is for what? This is for when y is equals to what? When y is equals to sine x, right? So for y is equals to sine x, we know that the minimum x value, so we know that the minimum x value is at negative 90 degrees and 270. But remember the fact that we're looking for g of x, meaning therefore for g of x is equals to now sine, that's going to be x plus 30 degrees, right? So we know the fact that the minimum value for when this one is like this is like this. What is the difference between these two? Is that a 30 is added. So we know the fact that here is the same as we having x is equals to what? X is equals to negative 90, and the other one is x is equals to 270. So what is the difference between this one and this one? This one is just x, and this one is x plus. So what we're going to do is that we're going to replace this x plus this one. So now we're going to solve for this one, which is going to be x plus 30 is equals to negative 90. Then the other one's going to be x plus 30 is equals to 270. So that's what we did. We just changed what our x is, right? Because of that's the difference between g of x and this y. Hope that makes sense, right? So now solving this is going to be basically equals to what? So let me just do this. Move this a little bit down. So for this one, it's going to be x is equals to negative 90 minus 30, right? So move this again down, right? Which is going to be equals to x is equals to 120, negative 120, right? So that's going to be that. Then this one is going to be x is equals to 270 minus what? Minus 30. Therefore, x is going to be equals to 240. So that's where your minimum values are going to be, which is these two values. Hope that makes sense, Anna. So now we're going to do 6.4. It says for which value of x will f f prime of x be less than 0. This means what? Let's translate this, right? When they're looking for the first derivative where it's less than 0, meaning we're looking for when f of x is decreasing. That's what it means, right? This is from calculus. So this is when f of x is decreasing, right? So what x values do you need? So the x values, so the values of x that we need to look at, so the values of x that we need to look at is what? Is your x coordinate. So it's going to be your x coordinate of the turning point, right? So we're going to need the graph. So now taking the graph, I'm going to just paste it here. So let me just delete this. So I'm just going to paste it here. Yes, so this is going to be your graph, right? So we're going to mark off the x coordinate of the turning point of f of x. I just wrote f of x alone, right? So we know that the turning point is going to be where? So your turning point is going to be here, right? And it's going to be here. So there we're going to have a solid line going down, marking it off like this. Just like this, right? Let me just fix this one. Just like this. Hope that makes sense, right? Then we know the fact that this is going to be the first. So from here, starting from here, going to here is going to be your first quadrant. And this is going to be your second quadrant. And lastly, this is going to be your third quadrant. Hope that makes sense, right? So we have that, right? Then now, to find increasing and decreasing is that going in this direction, right? Going from this direction to this side, right? Going from this direction, going like this, we're going to follow the graph drawing arrows. So going from which direction? From here, going to that direction, we're going to follow the graph drawing arrows, right? So we're going to do that. So it's going to be like this, drawing arrows, then going down, always starting from your left and right, following the graph and drawing arrows, following how the graph is basically going, right? So arrows that are going up, which we can see the fact that I'm going to highlight them with one color. Arrows that are going up, which is going to be yellow. This means what? This means that the graph is increasing. And arrows that are going down, that's going to be your portion where it's decreasing. So we see the fact that this first portion is, this represents when it's increasing because the arrows are going up. And also this portion, the third portion, is going to be increasing because the arrows are going up. Then the arrows going down is going to be decreasing. So where does your answer lie? So your answer is at 0 till negative 180. So that's where your answer is. So your answer for this question is going to be when x is an element, right? From where, since it's less than, do you see the fact that it's less than? So it's going to be from 0. So it's going to be from open bracket 0 degrees till 180 degrees. And that's how you would answer this question. Hope that makes sense, Anna. So now for 6.5, they say determine the amplitude of f. So this is the formula for the amplitude, right? So this is the formula for the amplitude. We need the minimum value and the maximum value. So remember the fact that we found the range, right, of f. So let's go back. Remember when we found the range of f, which this was the range of f, right? So I'm going to just duplicate it, cut it, right? So when we found the range, we know the fact that this is the range, right? The range gives us the minimum and maximum, right? So in range, this is our minimum value. So this is going to be our minimum and this one is our maximum, right? So that is that. So with that is that we can substitute. So we know the fact that amplitude is equals to our maximum is going to be a half, right? And this is going to be minus the minimum, which is going to be minus 3 over 2, right? And this whole thing is going to be divided by 2, right? So that is our minimum and maximum. Then now to basically sort this out, we're going to punch the numerator into the, let's first sort it out. So it's going to be 1/2 plus what? Plus 3 over 2, right? So when you say 1/2 plus 3 over 2, so when you go to your calculator, right, and say 1/2, so if you say 1/2, so when you say 1/2, right, plus 3 over 2, plus 3 over 2, plus 3 over 2, you get the fact that your value is going to be equals to what? So 1/2 plus 3 over 2 is going to give you positive 2 divided by 2, which now this is going to be equals to positive 1. Right, so that's your amplitude. Your amplitude is going to be positive 1. So now it says describe the transformation of f to h, right? And they gave us h. So first we need to see what a f of x looks like. We know that f of x is equals to, let's go up into the question. We know that f of x is basically equals to cos x minus 1/2. So you know that f of x is equals to cos x minus 1 over 2, right? We see the fact that the first thing is that we got rid of this, right? And that is q, right? It moves the graph up or down. So we got rid of this, meaning what happened is that to get this, we added by 1 over 2, right? So when we add by 1 over 2, this and this are going to cancel, which is now, we see the fact that that is basically going to be equals to cos x, right? And that is going to cancel, so it's going to be just plus cos x. So we see that by adding this, this is what plus 2 meaning it's going up. So we added, 1.5 units. Since it's positive, up. Hope that makes sense, right? Then we see another thing. We see the fact that our h of x has a negative, right? So we see the fact that h of x has a negative. So if we put a negative in front of it, so it's going to be just like that, right? A negative, this is basically having what? This is basically putting a negative in front of this one, right? If you put a negative in front of this one, we see the fact that that affects our graph, making it negative. So meaning if we put a negative in front of y, what is that? That is reflecting upon the x-axis, right? So by putting this negative, right, this is a reflection. So this is going to be reflected, right? Reflected about the x-axis. And I'm going to show you why about the x-axis. Because when if they gave you a question, they say the fact that f of x is reflected upon the x-axis, meaning the fact that you can write it like this. This is basically how you should write it, is that h of x is going to be equals to what? To negative what? Negative f of x. So this is affecting the what? This is affecting the y, right? Do you see the fact that this is affecting the y, and this is how we got here? Hope I'm making sense, right? So now to describe the transformation is that our graph, right? So to describe the transformation is that our graph moved 1 unit up, right? 1.5 units up, right? And was reflected upon the what? Upon the x-axis. So now explaining, right? The graph f, so the graph f, right? The graph f is what you call this, is shifted, because that's the first thing. It's shifted 1.5 unit up because it's positive, right? And reflected about the x-axis. So about the x-axis. Hope that makes sense, right? So that's how you would solve this question. So now we're going to do question 7, right? So question 7, it says, in the diagram below, PS is a vertical tower standing on a horizon plane, and they tell us that the plane is Q. So QR is, so this triangle is the horizontal plane, right? Then they tell us the fact that QR is equals to Y. Then they tell us the fact that Q1, right, is equals to alpha. So this is Q1, and Q2, which is this one, is equals to theta. Then this angle here, which is QSR, is equals to beta, right? So that's the information that they gave us. Then now they tell us the fact that, right, the shape of S, where is S, R, Q. So this angle, right, in terms of in terms of beta and theta, right? So we know the fact that since this is a triangle, right? So we see the fact that since this is a triangle, they gave us this angle and this angle. So using the sum of angles in a triangle, we can find this angle. So let's do that, right? So we know the fact that we know the fact that the angle that they want is SRQ, right, plus angle beta plus angle alpha is equals to 180 degrees, and that is sum of angles in a triangle. Sum of angles in a triangle. I feel like this pen is too thick, or it's the normal size. So therefore, we're going to take beta and alpha to this other side. So SRQ is equals to 180 minus beta, then minus alpha. I'm just going to pull out the negative, right, so that they can be inside a bracket. So it's going to be SRQ is equals to 180 minus open bracket. Anything that was positive becomes negative, and everything that was negative becomes positive. So it's going to be plus alpha. So that is writing your angle in terms of beta and alpha. Hope that makes sense. So now we're going to do 7.2. So it says show that PS. So you take your highlighter and mark PS what they want, right? PS smaller. So PS is this line, right? They say show that PS is equals to this, right? So looking at this, we see the fact that we need to have Y, so we're going to highlight Y. We see the fact that it has beta plus, so beta plus theta, so this one needs to be there. We need to have beta alone, and we have to have theta, right? So that's what we have, right? Then we see the fact that within theta, right, is going to be 10 theta. And we see the fact that the triangle where PS is lying is on this triangle. And I'm just going to highlight it in yellow, right? Is on this triangle. What do we see? We see the fact that since this is a right angle triangle, we can write theta. So we can find theta, 10 theta, right? So finding 10 theta, we know the fact that's going to be opposite over adjacent, right? So we know the fact that we need 10 theta because of that's what we have here, right? So we know the fact that 10 theta. So first we see the fact that, let me just increase my pen because, yes. So we see the fact that 10 theta, right, from this right angle triangle is equals to opposite, which is PS, which is great, which is what we want, divided by QS, right? So we know the fact that that is that, right? So we know the fact that it's equals to that. Make PS the subject. So it's going to be QS multiplied by 10. Theta is equals to what? Is equals to PS, right? So that is the first thing. Then we notice the fact that, do you see the fact that in this triangle, right, we need this side, right? But the nice thing is that, remember the fact that we can use sine rule. The reason why I'm saying you can use sine rule is that we need Y. So this and this sine beta is going to give me Y, and we're going to be covering the sine beta, right? And automatically we're going to have this Y. Then this one, what you call is beta plus theta, is going to be in reference to the side that we want, which is QS, right? So finding QS using sine rule. So I'm going to say finding QS using sine rule. So let's do that, right? So now let's do that. We know the fact that sine beta, right? So this to this, sine beta is going to be equals to what? And maybe let me just, we know the fact that the two are equals to each other, and the two are equals to each other, right? So we know that sine beta is going to be divided by Y is equals to sine, then it's going to be 180 minus, then it's going to be beta plus alpha, right? And that is going to be divided by what? By QS, right? Then now let's reduce this because this is reduction, right? So we know the fact that this is going to be sine beta divided by Y, and this is from the first quadrant, so everything is positive, so it's going to be sine, then it's going to be beta plus alpha, right? And that's going to be divided by what? By QS. So I'm going to basically make QS the subject because I want to substitute it back here, right? Hope that makes sense. So now it's going to be what? It's going to be QS, right, multiplied by sine beta is equals to Y multiplied by sine, then it's going to be beta plus alpha, right? So it's going to be QS is equals to Y sine beta plus alpha is divided by sine beta, right? So now if you look at it, this, right, it's everything that you need here, right, besides this 10. So now we know the fact that therefore PS is equals to what? To QS multiplied by 10 alpha, 10 theta. So now let's substitute QS. So PS is equals to what? Is equals to Y, right, multiplied by sine. Then it's going to be beta plus alpha, right? And this whole thing is divided by sine beta, right, multiplied by 10 theta. So therefore, PS is equals to what? Is equals to Y multiplied by 10 theta multiplied by sine beta plus alpha. And this whole thing is divided by what? By sine beta, which is exactly what they wanted. Hope that makes sense, Anne. So now we're going to do 7.3. They say hence or otherwise, our hands is going to be this thing, right? Determine the length of PS, and they give you the value of y, theta, beta, and alpha, right? So our hands is what? It's this whole thing, right? It's this answer. Cut. So that's our hands, right? So we're going to use this. So put that into a square bracket. Put that into a square bracket. So back to red. So this. Oh, delete this. Okay, put this into a square. What's happening? Put this into a square bracket. Right? Then we know the fact that PS, we're going to substitute all the values that they gave us. So it's going to be PS is equals to our y is what? 116, right? Then that's going to be 10. Then theta is 57 degrees. Then it's going to be plus sign. Then this is going to be beta. Beta is 102. Then plus 27, right? And that is going to be divided by what? So that's going to be divided by what? This is going to be divided by sine. And our beta is 102. Hope that makes sense, right? So we're going to have that. Then now we're going to clean up the 102 plus 27. So we know the fact that PS is going to be equals to 116. Then it's going to be 1057, right? And this is going to be sine. And this is going to give me 129. And that whole thing is going to be divided by sine 102. Then what we're going to do is that we're going to punch this whole thing into the calculator. Therefore, PS is basically equals to 141,92, right? So it's going to be 149,92. Then the unit is meters. So that is what we're going to have. So now we're going to do 7.4. It says, determine the angle of evolution from R to P. Angle of evolution is looking up. So do you see the fact that this is R? So it's from R to P, meaning it's this angle. So the angle of evolution is going to be this angle. Hope that makes sense, right? Because this is a flat surface. So if I'm at point R and I'm looking up, that is going to be my angle of evolution from here to here. So this is the angle. Hope that makes sense, right? So we're looking for this angle. This is the angle in question that we're looking for, right? So that's the angle that we're looking for. That's the angle of question, right? Then now, let's see how we can find. We know the following. So I made a mistake this here, right? We know the fact that this side is, this PS is equals to what? From our previous question, we know the fact that it's 141. So we know the fact that this is 141,92, right? So we know that, right? So to find that angle, the nice thing, we know the fact that this triangle, maybe, and let me highlight it. We know this triangle, right? It's a right angle triangle. So I can use trig ratios, right, to find this angle. So we see the fact that the angle that we want, if we're using trig ratios, is going to be what? If we find opposite over adjacent, right? The reason why I'm saying adjacent is because of I can find this side. And the reason why I can find this side is using this triangle and using sine rule. Hope that makes sense. How we did this one, this is how we're going to do this one, right? So we know the following. We know the fact that using, in triangle, PRS, right? We know the following. We know the fact that 10 of that angle that they want, which is going to be angle PRS, right, is equals to opposite, which is going to be PS, which we have, right, divided by what? Divided by SR. Right? So we have that. So now we know the fact that PS is equals to 141,92. That is nice. Now now we're going to be finding SR, right? So finding SR in triangle. So in the triangle SRQ, right? We know the following. We know we're going to use sine rule. So we know we want this side. So it's going to be this one is to this, right, divided by either this one is to this or this one is to this. It doesn't matter. No, it's going to be definitely this one is to this, then this one is to this, because we do not know what SQ is, right? So it's going to be this to this because we want this one, then this and this because it's complete. Hope that makes sense, right? So it's going to be what? It's going to be it's going to be SR divided by, so SR is sine this 27. So it's going to be sine alpha is equals to what? It's going to be equals to QR, right, divided by what? By sine beta, right? So now let's clean this up, right? So we know the fact that SR, make it the subject, so it's going to be equals to QR multiplied by S alpha, then divided by what? Divided by sine beta. So now we can substitute the values, right? We can substitute the values. So substituting the values is going to be what? We're going to have the following. So substituting the values is going to be SR is equals to QR. So QR, we know the fact that it's going to be 116, right? Then it's going to be sine. Then it's going to be sine alpha. So sine alpha is going to be what? It's going to be 27. So it's going to be 27, right? And this is going to be divided by sine beta. So we know that beta is going to be what? Beta is going to be 102. Hope that makes sense, right? So we have that, right? So now we know the fact that it's this. We're going to punch this into the calculator. So we know the fact that SR is going to be equals to what? It's going to be equals to 53, comma what? Comma 84 meters, right? So now we know that, therefore, we're going to just substitute it back here. So therefore, we know the fact that 10, and maybe let me just copy and paste it. So we know that this now duplicated, cut it. So therefore, we know that this, so therefore we know that this is going to be equals to 10 PRS is equals to what? So just 10 PRS is equals to PS. We know the fact that it's 141, comma what? Comma 92 divided by SR, which is going to be 53, comma 84, right? So we know that. So now to find the angle is going to be arc10. So it's going to be PRS is equals to arc10 of 141,92 divided by 53,84, right? Then you punch that into your calculator. You're going to find the fact that your PRS is equals to what? Is equals to 69,23 degrees. So that's how you would find your angle. So now we're going to do Euclidean geometry. We're going to do 8.2, but 8.1 is actually a proof, right? So I'm not going to do the proof because I've already done the proof in the master series, right? In the master Euclidean. So what I'm going to do is the following, is that I'm going to put the link to the section where I prove the specific proof in the whole master series. So don't worry, it's going to be just this portion so that you can see how you can prove this. Hope that makes sense. So now we're going to start with 8.2, right? So with 8.2, it says PR is a tangent to the circle at Q. So they tell us that PR is a tangent at the circle, right, of the circle at Q. So now I'm going to draw a line going to PR, but I'm going to start, let me just reduce this. Okay, cool. So we're going to reduce this. Okay, let me just reduce my highlighter. So PR is this line, right? I'm going to start with this section of the tangent, right, meaning the tangent PQ. Then I'm going to draw a triangle. So we know the fact that this is a chord, right? And make sure the fact that the triangle that you're drawing touches the circumference. Do you see the fact that it touches the circumference here, here, and here? And only then you can say 10 chord, right? So we know the fact that therefore this angle here, so this angle here, right, is equals to this angle. And that is 10 chord. So we know the fact that that angle is equals to each other. Let me erase this, right? And now let me draw the tangent on the other side, which is this tangent on this side, right? Then we connect it like this, right? So let me just do that. So like this. Then we see the fact that this one is equals to this one. But we already know that this angle is equals to 57 degrees. Now, before we even just continue reading the full statement, so we know the fact that this is related to tangent, right? Is that we can find what is W1, right? So we see the fact that we given what? We given this angle, we given this angle, then meaning we can find that angle that is going to be sum of angles in a triangle. So we're going to say triangle. So my first statement, even going to 10 chord, I'm going to say what? I'm going to say triangle, and I'm going to do it in green, right? So I'm going to say triangle properties. So properties, right? Then I'm going to do this. So with the triangle properties, we see the fact that we have the following, right? Is that we see the fact that angle W1, right, plus angle 57, then plus angle 67, adds up to 180 degrees. And that's going to be sum of angles in a triangle. So that's going to be sum of angles in triangle, right? Hope that makes sense. So now, since W1 is the only unknown, we can basically what? We can solve for it, right? So we see the fact that angle W1, so we're going to say angle W1 is equals to 180 minus 57, then minus 67. So when you do that into the calculator, so if you say 180, so it's 180, right? If you say 180, then you say minus 57, then minus 67, you find that your answer is going to be equals to what? Angle W1, it's going to be equals to 56. So the green angle is equals to 56. Then we also know the fact that this is also equals to 56. Hope that makes sense, right? Then now we can move into what? Into the properties of the of the blue angle, right? So we know the fact that, and let me just make it red because my highlighter was red, right? So let's make it red. Let me just erase this. We know the fact that 10 chord, we know the fact that this one is red and this one is red, and that is 57. All right, now we can move to tangent, properties of a tangent. So with tangent, we know the following, right? First, we know that they're 56. So we know the fact that angle W1 is equals to what? It's equals to angle Q3, right? Which is equals to 56. So, and the reason is 10 chord theorem, 10 chord, right? So we know the fact that the reason is 10 chord. Now moving to the red one, we see the fact that Q1 is equals to, let's name that angle is WSQ, which is equals to 57. And that is 10 chord theorem. Hope that makes sense, right? So we're done with the statement. Now moving to the next statement. So let's move to blue. Yes, let's move to blue, right? So let's move to blue. So they tell us the fact that QWZ is a straight line, right? So that doesn't tell us anything. Then they tell us the fact that QSVW are points on the circumference. So having points on the circumference, meaning we need to think about all the properties that related to a cyclic quad. So we see the fact that this is the 4 points, right? So we see the fact that this is the points on the circumference. But the nice thing about that is that you see the fact that this is outside, right? And external. So we see the fact that using the blue one, so using this, is that this angle here is equals to this entire angle. And that's what? Exterior angles of a cyclic quad, right? So I'm going to say cyclic. So I'm going to make them, maybe, let me just do this. Okay, go. So this, right? Then I'm going to just write monodes this side. So I'm going to say cyclic, points on the circumference. So it's going to be point on circumference, point on circum. So we see the fact that the following, right? We see the fact that angle, this whole angle is, right? So we see the fact that angle is, so we see that angle is, right? Is equals to what? Is equals to, let's name that angle, which is VWZ. It's equals to VWZ, right? Which is equals to what? Which is equals to 108. And that's what? Exterior angle of cyclic quad. Hope that makes sense. But the nice thing is that angle S is made out of what? It's made out of 57 plus S1, right? So we can find S1. But we see the fact that S, right? So angle S is equals to 57 plus S1. But we know that angle S is 108 is equals to 57 plus S1. So we can find angle S1, right? So we know the fact that 108 minus 57 gives us angle S1, right? Hope that makes sense. So with that said, is that we can punch, what you call this? We can punch this into the calculator. So when we punch that into the calculator, if you say 108 minus what? Minus 57, that is going to give us what? 51, right? So therefore, we see that angle S1 is equals to 51 degrees. So now going back into the diagram, we know the fact that this angle is equals to 51 degrees. Hope that makes sense, right? So that's what we have. Then another properties that we see is that we know the fact that opposite angles of a what? So we know the fact that opposite angles of a cyclic quad are supplementary. They add up to 180 degrees, right? So now we know the fact that other properties, so we know the fact that there's two, they add up. So if you take this one and this one, they're gonna add up to 180 degrees. So now let's do that. So we know the fact that, so we have green. So let me go to maybe the darkest purple, right? So we know the fact that this and this, they add up to 180, right? So we know the fact that now, maybe let me just do here from properties. So we know the fact that angle Q2 plus angle V. So we know the fact that angle Q2 plus angle V is going to be equals to 180. And that's what? Opposite angles of a cyclic quad. So that's opposite angles of cyclic quad. So cyclic quad. Right, so we know the fact that angle Q2 is 67. So we know the fact that this is 67 plus angle V is equals to 180. So now we can find angle V, which is going to be what? Which is going to be 180, right? Minus what? Minus 67, which is going to be equals to 113. So when you say 180 minus 67, we see that angle V is equals to what? Is equals to 113 degrees. So we see the fact that this angle here is equals to 113 degrees. So with that, we can also find this angle, right? Because opposite angles of a cyclic quad, right? So we know the fact that that too also. So we see the fact that we can also find this angle, or what you call this WV, right? So we see the fact that angle S, right? We also see that angle S. And I'm just going to do it in purple too, so that there's consistency. So we know the fact that angle S, right, plus, let's name that angle VWQ. So it's going to be VWQ is equals to 180 degrees. And we know the fact that that's what? Opposite angles of a cyclic quad. Opposite angles of cyclic quad. Cyclic quad. Hope that makes sense, right? So we can find angle S. So we know the fact that angle S is what? Is equals to 51. So that whole angle is equals to 51, right? Degrees. We know the fact that that whole angle, no, it's not equals to 51. We know that this whole angle here, very important, this whole angle here is equals to 108, right? So 108. We know the fact that that whole angle, so maybe let me just do this. We know the fact that this whole one in blue, it's 108 degrees. Then just the small one, just this one, and maybe let's do it in a different color, just the small one. We know the fact that that is 51 degrees. Hope that makes sense so that there isn't any confusion. So now with that, we know the fact that the whole angle, it's 108. So it's 108. So we know the fact that the whole angle is 108. And we know that W is made out of what? It's made out of W1 plus W2, the angle that we're talking about. So it's W1 plus angle W2 is equals to 180. But we see the fact that W1 is equals to 56, right? So we know the fact that 108, right, plus W1 is 56, right? So W1 is 56. So we know the fact that this is 56 plus we're looking for W2, right, is equals to 180. So take everything to one side. So it's that angle W2 is equals to 180. So it's going to be 180 minus 108 minus 56, right? So we have that, right? So now with that said is that we're going to punch that into the calculator and find angle W2. So if you say 180 minus 108 minus 56, we get the fact that angle W2 is equals to 16 degrees, right? So this angle is equals to just the small angle, right? And let's make it a different color. Just this angle is equals to 56, not 56, it's equals to 16 degrees. And now we see the fact that our entire diagram is filled up, so that we can go and answer the first question. We can go answer the question. So now we're going to do 8.2.1. It says determine the size of V. So let's go up and see where V is. We see the fact that V is here. How did we get V to be equals to 113? We know the following, right? Remember from the property, we know the fact that angle Q2 plus V is equals to 180, and that's opposite angles of a cyclic quad. And therefore, substituting this as being 67 because it's given, we can solve V as being 113. So let's do that, right? So we know the fact that angle V, so it's going to be angle V plus angle Q2 is equals to what? So angle V plus angle Q2 is equals to 180 degrees. And our reason for that is opposite angles of a cyclic quad. Opposite angles of a cyclic quad. Right? Then we know the fact that angle Q2 is equals to 67. So we know the fact that angle V plus 67, let's just make sure, is equals to 180 degrees. So therefore, we know that angle V is equals to what? Is equals to 113. So let's just do this. It's going to be 113. Let's make sure 113 degrees. Hope that makes sense how we got that, right? So now we're going to do 8.2.2. It says we need to determine S1. Let's go back to the diagram. We see that S1 is here, right? And that's equals to 51. So how do we get that? We know the fact that this angle here, right, is equals to this whole angle that has S1, and that's 108. That's exterior angles of a cyclic quad. And we given that 57 is made out of angle S, is made out of 57 plus S1, right? So now let's establish that, right? So we know the fact that angle S, so first you're going to start by saying angle S is equals to what? To angle, to this angle here, which is VWZ. So we know the fact that angle S, so angle S is angle S is equals to angle. So you can just not name it. We can say angle S is equals to 108, right? So we know the fact that angle S is equals to 108 degrees, and the reason is exterior angles of a cyclic quad. But we know that angle S is made up of what? It's made up of 57 plus S1. But we know the fact that angle S is basically angle S1. Right, so it's going to be angle S1, what we want, plus what? Plus 57, right? So it's going to be plus 57. And that's going to be equals to 108. So to find S1, take the 57 to the other side. So angle S1 is going to be equals to 108 degrees minus 57 degrees. And we know the fact that that is equals to 51. So that is going to be, therefore, angle S1 is equals to 51 degrees. So now we're going to do 8.2.3. We need to find WQR. Let's go find it. W. So it's WQR. We see the fact that it's this one. We see the fact that from this one, this was 10 chord. So angle Q1, which is the one that WQR, is equals to 57, and that is 10 chord. So let's do that. So we know the fact that I'm just going to name it the way they name it. So it's just WQR is equals to, let's go back, it's 57. So it's 57. And remember the fact that the reason is 10 chord theorem. So now we're going to do question 9. So with question 9, they say, in the diagram, they tell us A, B, and E are the points of the circumference, right? So they tell us that this point, and this point, so this triangle is the points on the circumference, right? So also, they didn't tell us the fact that this is a diameter, so don't go and say this is 90. They just told us the fact that this is other points on the circumference. Then they tell us that AB, so AB, right, produced to meet EC. So we see the fact that it's produced to meet EC. So we see the fact that they meet here at C, right? And they tell us the fact that EC is produced to meet D. So we know the fact that here, like this, at D, so here. Then they tell us the fact that EC is a tangent. So here's the first important information. They tell us the fact that EC is a tangent. So we see the fact that is a tangent at point E. So we see the fact that this line here is a tangent, right? So with it being a tangent, how I'm going to do it is that I'm going to start it from here. So it's going to be, I'm just going to look at it from this point, from here, right? Reason why is that I want to show you how it's 10 chord from that point of view. Hope that makes sense. Since we have 3 points that are on the that are on the circumference and they all connect, we see the fact that it creates what? It creates a triangle like this. Therefore, we see that this angle here is equals to this angle here, right? And that's 10 chord theorem. So we see the fact that I'm going to say tangent. So here I'm going to say tangent. Then I'm just going to underline it. We see the fact that angle E1 is equals to angle B1. And the reason is 10 chord theorem. So it's going to be 10 chord theorem. Right? So we sorted with that one. So now I'm going to do the triangle from the other side. So it's going to be from this side. But now I'm going to draw the triangle like this. Then I'm just going to change my color pen, right? So maybe I'm going to make it orange. So we see the fact that this angle, E3, right, is equals to this angle A. So we see the fact that angle E3 is equals to angle A, and reason is 10 chord theorem. So that sorts out everything that is related to tangent, right? So erase this. So that sorts out everything that's related to tangent, right? So now we continue with the question. They tell us the fact that the line CT, so this line CT, so this line here, right, is equals to this line. We see the fact that if there's two lines, you see the fact that when I do this, this creates a triangle. So let's highlight it, right? So maybe we'll do it in red. You see the fact that they tell us that this line, right, is equals to this line. The nice thing that we see the fact that this creates a triangle. Since opposite sides are equal, that means the fact that opposite angles are equal. So what do we see? The fact that, so under what? Under, what do I want to say? Under this, I want to say the following. So under CT, yes, under CT being equals to CE, right? That's what I wanted to say. They tell us the fact that they're equal, right? So we know the fact that angle E4. So let me just mark it. We know the fact that this angle and this angle are equals to each other. So we see the fact that angle E4, right, is actually equals to what? To angle D. To angle D, right? And that is what? Opposite sides equal opposite angles equal. So now in terms of the statement, we kind of done, right? But we look at something. We see the fact that this line and this line. So do you see those two lines, right? And maybe let me just erase this because I want to show you something, right? I think it's something that a lot of students might forget is that do you see the fact that this line going down and this line, right? They intersect here, right? Meaning vertically opposite angles are going to be possible. So we see the fact that one, do you see this angle here? This angle, green angle here is equals to this angle here. So E1 and E4 are equals to each other. So I kind of need to update this red one into being green, right? Let's update it to being green. And the reason why I'm updating it to be green is because of, we know the fact that that two is vertically opposite angles. So I'm going to say lines. So I'm going to say lines in orange. So maybe let's pick orange. Oh, we're not going to see orange. Let's make it in, let's make it in blue. I'm going to just say lines. Right? Lines. And I'm just going to underline it, right? So within lines, we see the fact that angle, and I'm going to do it in green, right? Then I'm going to update the rest. We see the fact that angle E1 is actually equals to angle E4, right? And that is vertically opposite angles. That's vertically opposite angles. Hope that makes sense, right? So since now that is green, why didn't I do it in green? I'm so sorry. I needed to make it in green because you guys need to see it, right? You need to be able to see it. And let me just move the lines up. Yes. Is that angle E1 is actually equals to angle E4, right? And that's vertically opposite angle. So that's vertically opposite angles. Hope that makes sense, right? Meaning now it updates this one, meaning this one is also green. It's no longer red. So I'm going to do this. I'm going to highlight that in green. I'm going to highlight this statement in green now. Maybe let's make it a little bit big. We're going to highlight that. We know the fact that now it's green because of that property, right? So with the vertically opposite, also we see the fact that these two angles are also equals to each other. This one and this one. And since they didn't name us this one, right? Don't mind it. Don't mind it. They didn't give us a number here. If they gave us a number, then you are going to put the property. But half of the time, if they don't, you can't name this. Because you see the fact that DE what? There isn't any point just. Since you can't name this, leave it. I don't think it's that important, right? But if they name it where you see the fact that there's numbers, sometimes it's very important to name it. Hope I'm making sense, right? But looking at it, I think so far with what we're given, this is what we have so far, right? this is where we can end. So now we can go answer the first questions. So question 9.1, it says prove that BCDE is a cyclic quad. So I'm going to highlight what they want, which is B, go back, make it small, right? BCDE, right, is a cyclic quad. So with proving a cyclic quad, you have three properties, right? So first, you can prove the fact that if you have lines going across like this, so in our case, there's two lines that are crossed, you can prove the following. You can prove that this and this are equal, or you can prove that this and this are equal, and also the other side, you can prove this and this are equal, or this, right? So this, okay, cool, it's this and this, or you can prove this and this are equal, right? We see the fact that we do not have enough information to prove those, like angles in the same segment. We do not have it, right? Then another one that you can prove, so let me just delete this, right? Another one that you can prove is that when you add this angle and this angle, it needs to add up to 180. But since they didn't give you the actual values, it's hard to prove that one, right? So that one is out too. But we see the fact that in terms of the cyclic quad that we're proving, if we extend the lines like this, right, we see the fact that another thing that we can prove the fact that this exterior angles of a cyclic quad, meaning this and this, are equal. And we see the fact that these two are the same color, which is green, right? So we can prove the fact that since these two are equal, then that is a cyclic quad. So that's what we're going to do, right? So how did we get the fact that these two are equals to each other, right? So we know the fact that E1 is equals to what? We know the fact that E1 is equals to E4, right? And the reason why we know that E1 is equals to E4, that's vertically opposite angles. But the nice thing is that E4 is equals to this angle D, right? And also we know the fact that E1 is equals to angle B1. So therefore making these two equals to each other. Hope that makes sense, right? So now we're gonna basically prove it, right? So I'm gonna start establishing the relationship. So we know the following. So we know the fact that angle E1, right, is equals to angle E4. And our reason is going to be what? Vertically. So that's vertically opposite angles, right? So that's the first thing. So this part is out. How we link it to that. Now we're going to link. Remember, the goal is to prove that true. Let me just write up here goal, right? Goal is to prove that B1 is equals to angle D. That is the goal. So the goal is to prove that that two is equals to each other. So maybe let me put it in red so that we know where we're going. Hope that makes sense, right? So now we know the fact that these two are equal, but we know the fact that this and this are equal, which is great because we're getting close to the goalpost, right? So we know the fact that angle E4 is actually equals to angle D, right? And that is what? That is, since we know the fact that these two lines are equals to each other, that's isosceles triangle, right? So that's angles opposite. So it's going to be angles opposite, right, equal sides. Hope that makes sense, right? So now we know the something. We know the fact that since that two exists, right, now we need to map it up to this one. We know the fact that angle E1 is actually equals to angle B, right? So we know the fact that E1 is equals to angle B, right, B1. And our reason is what? Is 10 chord theorem. 10 chord theorem. Then what do we see? We see the fact that everything is equals to each other here, and we have BD and angle B1. So therefore we can conclude that angle B1 is actually equals to angle D, right? And now since we know the fact that that is equals to each other, now we can conclude the fact that, therefore, we know the fact that BCDE, right, is a cyclic quad, So it is a cyclic quad, right? And what is our reason? It's going to be converse. Remember, since we're proving, so it's going to be converse. That's exterior angles of a cyclic quad, right? So it's going to be converse. Then it's going to be exterior. So you write the reason. So when you're proving, you're going to say converse. Then you write the reason, right? Exterior angles, right? So it's going to be exterior angles. So it's going to be exterior angles of cyclic quad. And that's how you would basically answer this question. So now we're going to do what? We're going to do this question. But before doing this question, which is 9.2, which we need to prove those two triangles are similar, we need to update the properties. So since now we know the fact that this 2 is a cyclic quad, let's update it, right? So we know the fact that if that is a cyclic quad, now let's update the properties. So we know the fact that, so I've used, okay, now I need to use blue. So we know the fact that now E2 is equals to this angle C. That's exterior angles of a cyclic quad. And we also see the fact that we can create the angles in the same segment. So let's do that, right, with angles in the same segment. So we see the fact that here, do you see that orange one, this orange angle, right? Do you see this orange angle here needs to be equals to this small one? So we see the fact that that is equals to this one, right? Then we see the fact that also, so I'll use green. So we see the fact that this, no, that's not going to show. We see the fact that this and this are also equals to each other. Then the other way, so purple, we see the fact that this and this are equal. So no. So since this is already green, so that means the fact that this is also green, angles in the same segment. Then lastly, from the other side, we see the fact that, we didn't use red. We do not have red. We see the fact that this one is also equals to this one, right? So that is us updating the diagram, right? So the goal is to prove that triangle CEB, right? So CEB, so let's do that. Let's highlight C, E, B. So this triangle, right, is similar to which triangle? Let's make it in blue. Is similar to the triangle CA. So this big one, CA. So it's going to be CAE. So it's going to be this triangle. So that is the 2. So without even just doing anything, we need 3 statements. Actually, you need 2 angles. You need to prove that 2 angles. Then the other one is going to be sum. So we see the fact that the first one is angle E2. Both of them, they share, both the red triangle and the blue one share this E2 as being common. So that's 1. That's great. We need a second one. We see the fact that this one is orange and this one is also orange, right? So that means what? That means the fact that that's our second angle. Then the remaining angle is going to be sum of angles in the triangle. Then that proves that this is similar. Hope that makes sense, right? So now we're going to say in. So let me go. You're going to say in triangle CEB and triangle CAE, right? So the first statement is that angle C2 is common. So that's great. The second one, we see the fact that this one, this orange one, right? If we go back, that was 10 chord, right? Do you see? That was 10 chord. So we see the fact that angle E2, so angle E3, sorry. So angle E3, let's go up. Yes, it's angle E3 is equals to angle A. And our reason is 10 chord theorem. Then now, the last statement is that from the big triangle, right? So from this big triangle, which angle is missing is going to be this angle. So the angle that's missing is going to be AEC. So it's going to be AEC. So it's going to be See, then from the red one, we see the fact that this is gone, this is gone. The one that's remaining is this one, which is EBC. So it's going to be E is equals to EBC. And our reason is going to be sum of angles in a triangle. Sum of angles in triangle. So therefore, triangle CEB is similar to triangle CAE, and your reason will be angle, angle, angle. Hope that makes sense, Anna. So now we're going to do 9.3. So they say the fact that we need to prove that this is equal. So the best way is that each side, right? Do you see the fact that each side, mark it off in the diagram, right? To see what you're dealing with. So normally it's two options. If you had parallel lines, then your brain was going to think about the proportionality theorem, right? And also similarity. But here we know the fact that our diagram didn't talk about any parallel lines. So parallel lines don't play a role here. So meaning the next best thing is similarity, right? And normally if you have proven similarity in the previous question, so that the following up is going to use that similarity. Hope that makes sense, right? So now, but it's very important to mark it off so that you can see what you're dealing with, right? And I'm going to also show you another simple way to actually get the ratios. But let's start. So CD, right? So we know that CD is here. So it's this line. Right, we know that CD is that line. Then we know the fact that they want in the ratio, so CD is out. Let me put it. Then we need EP. So EP is this one. EP is this one, right? Then we see the fact that AC. So AC is going to be from here to here. So we see the fact that EP and AC. Then AE. So AE is going to be this one. So what do we see? We see the fact that all the lines, right, are from the triangle that we proved in the previous question. Do you see that? Maybe let me just unzoom it so that you can see. Do you see the fact that all the lines, right, all of them, not all necessarily all, besides this one, is that it's from this triangle, right? But what do we know about this one is that this line is actually equals to this line, and that line belongs into this triangle. So definitely to get this, you need to use what? You need to use your triangle, your similarity triangle, right? You need to use this similarity triangle, and I'm going to copy and paste it, and I'm going to show you why I'm copying it and pasting it, right? Is that since we know the fact that the properties is from there, right? Is that now let's match up what they want, right? We know the fact that, so first we know that, so first this is going to be what we're going to use, right? So I'm going to put it there. Okay, cool. I think let me just do this first. We know the following. We know, just don't want to confuse you. We know that CD is equals to CE, right? So we know that. So meaning I can start using CE, right? Then at the end, I'm going to substitute it to CD. So now using the statement, right, that these two are similar to each other, that's what we're going to use to create the ratio. How they positioned, right, is very important. Is that when proving similarity, is that how you call each triangle is how equal the angle is. Meaning in our case is that we know the fact that from this triangle CE, so CEB, right, we know the fact that if it's CEB, meaning the angle C, right, is equals to this angle C, which is we see, right, E, right, E, which is in our case is this one, is also equals to the angle A. Do you see? And angle B is equals to what you call this, to the angle E, right? So this angle. So how they are situated is how their angles are equals to each other, right? Meaning their ratios, we can actually pick up the ratios from here. Hope that makes sense. So now looking at our equation, right? Remember the fact that CD is replaced by what? By by CE, right? So now we're going to highlight the way it is, right? So the first one, they tell us the fact that they want CD, which is, we know the fact that in our case is CE. So CE, if it's going to be CE like this, then it's going to be the ratio that's going to be divided is going to be the same one on the other side, on the other triangle like that. Hope that makes sense, right? So we see the fact that it says CE, which is CD, right? So we see the fact that CD, right, which is CE, is equals to CA, which is in our case is AC, right? So we see the fact that we have that. Then the next one that we need is what is EP. So go here, we see that EP is this two, right? So I'm going to highlight it with a different color. So I'm going to make it red. So we see the fact that EP, right? So on the other side, meaning it's going to be AE, right? So we see the fact that EP, so EP, which is this one, and AE is this one. Do you see the fact that the entire ratio is gone, right? So now that's sorted. So now let's write it, right? It's going to be what? It's going to be CE, which is the blue one, divided by CA is equals to EP, right? And whatever you're going to start this side divided by the other side. So this one is going to be on the numerator and this one's going to be on the denominator. Then it's going to be EP divided by what? Divided by AE, right? Remember the fact that CE is the same as ET, so we're going to make that the subject. So it's going to be CE is equals to EP, right? Multiplied by CA divided by AE. Do you see the fact that that's exactly what they want? This and this is exactly, but we know the fact that that 2 is equal. So therefore, we know the fact that CD is basically equals to EP multiplied by CA divided by AE. And here, don't forget your reason. So your reason is because of triangle CE. B is similar to triangle CAE. And that's how you would solve this question. Hope that makes sense, Anna. So now we're going to do 9.4. It says CD is a tangent. So a CD, so CD. So let's highlight that. So they say we need to prove that CD is a tangent to the triangle A. So the triangle AB, ABD, so this triangle, right? So is this, and I'm just gonna draw a whole circle there. So our circle goes like this, 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 and this. It looks more of an oval. I just want you guys to see the picture, right? But they saying the fact that this circle, right? So let's just maybe change the opacity, right? So they tell us the fact that this is the circle that we need to prove the fact that CD is a tangent. So we see the fact that this is a tangent and we need to prove the fact that this angle is equals to this one. And we see the fact that that actually is true. We see the fact that this angle here is orange and this one is orange. So we see the fact that this angle here, D2, is actually equals to this angle. But how did we get there? How did we get there? We know the fact that these two are equal because that's 10 chord, right? From what we have, let's go up, right? We saw the fact that that's 10 chord. But most importantly is that remember the fact that after proving that this is a cyclic chord, we know the fact that these two are going to be equals to each other. There's angles in the same segment. So what we're trying to prove, we want to prove that angle D2 is equals to angle A. So let's do that, right? And we see the fact that they're actually equals to each other. So let's put that. So now we see the fact that angle E2. So we know the fact that angle E3 is equals to angle A. And you can say proven, right? Proven in. You proved it in this question, in 9.2. So we proven in 9.2. That's 10 chord, or you can say 10 chord again, right? Then we know the fact that angle E3 is also equals to angle D2, and that's angles in same segment, right? So therefore, we see the fact that therefore angle D2 is actually equals to angle A, right? So therefore you can say CT is a tangent. And what is your reason for that? Because you are proving it's going to be converse. So converse, right? What's going to be converse is going to be 10 chord theorem. Hope that makes sense, right? So that's how you would do this question. So now we're going to basically prove this one. They tell us the fact that EB squared, right, divided by AE squared is equals to BC divided by AD, right? So what I'm going to do is that with this type of question, and this is a thumb rule, right? Just put it up there. Remember the fact that with proving ratios, it's either you need proportionality theorem or similarities, right? So with our case, we know that the proportionality theorem is not going to work. So if you see square, right, just know the fact that you need to kind of use, especially if it's a ratio like this, right, is that you need either like two sets of ratios, then when you equate them, then it's going to give you the square. Hope that makes sense, right? So we know the fact that we have the first set of ratios, which is the one that we already did here. In terms of this one, right, we can create ratios from this. But to create the square, meaning if we had parallel lines, is that we were going to use that proportionality theorem, but we know the fact that we do not have that. So what I'm trying to say is that we're going to need two sets, meaning we're going to either need to prove another two triangles are similar. Hope that makes sense, right? So first what I'm going to do is I'm going to color coordinate. Wherever there is EB, wherever there is a square, I'm going to mark it with a different color. So that color would be maybe red, right? The EB and AE is going to be red. So where's EB? EB is this one, right? We know the fact that that is squared, and AE, it's this one. So we see the fact that those two ratios are squared, right? And I'm going to come back to what they're going to mean. Then BC, we see the fact that we need BC in our answer, and we also need AE. So we see that, right? So first, what we like is that this one, right, is from our old triangle, right? Because of, remember the fact that this big triangle, that's good. And also AE, the one that's squared, and this one is from our old triangle. And also this BC is from our old triangle, so that's good. But the problem is this two now, right? The problem is this two, is that we need another triangle in such a way, the fact that, do you see the fact that the other set of triangles that we need to prove similar, it needs to have this again, need to have AC and BE again, right? So yes, AC and BE again, so that the square can come into place. Hope that makes sense. So now what we're going to do is that for that one, because of we need another triangle to prove that it's similar, so we need this triangle. So we need to prove that this triangle is similar to another triangle. So now looking at our triangle, we have the fact that we have this triangle, right? Yeah, no, it's not gonna play. But we see the fact that if you look closely, right, is that you see this orange matches up with this orange. We see the fact that this green matches up with this green. And lastly, this blue matches up with this blue. So step number one, we need to prove that the red triangle is similar to the yellow triangle. And when naming it, so this is going to be the first triangle. So I'm going to name it as triangle. And it's going to be EAB, right? So when you say, so you're going to say in triangle EAB. So we know the fact that E is here and E is going to match up with C. So meaning and triangle C, right? So it's going to be CDB. And what do we see? Do you see the fact that they match? E is to C, right? A, right, is to D. Then lastly, we see the fact that B is definitely it to B. Hope that makes sense, right? then we're gonna just prove. So the first one is going to be what? I'm gonna prove the angles. So I'm gonna start with the way the angles are just written here, right? Just this order. So we know the fact that angle E, which is going to be this one, right? We know the fact that angle E2, right, is equals to angle C. And what is our reason? Our reason is exterior angles of a cyclic quad. Exterior angles of cyclic quad. Cyclic quad. Remember that when we proved that this is a cyclic quad, right? Ooh, go back. When we proved that this is a cyclic quad. Hope that makes sense, right? So the next one is angle A, right? So we see the fact that angle A is this one. We already proved that the fact that the two are equal. So we know that angle A is equals to angle D2. And our reason is proven in. So we proved it when we were doing this question, the tangent one. So we proved it in 9.4. Right? So number 3, which is going to be the remaining one, is that angle B. So we see the fact that B1 is equals to B3. You can say B3. And it's going to be sum of angles in a triangle. Sum of angles in triangle. So therefore, we see that triangle EAB is similar to triangle CDB. And our reason is going to be angle, angle, angle. Hope that makes sense, right? So now we're going to use this ratio. Remember the fact that our goal is to have this two there, right? So our goal is to have this two there, and from that triangle, from the green, from the red, and this is our goal. And we see the fact that the BC is shared too. So meaning it's either our BC can be matched, but our goal with this one is to have this, and maybe from the other one we need this and this. But all this is what's very important. So we're going to start there, right? So we know the fact that we need what? From this triangle, we know the fact that we need AE. So we know the fact that we need AE, and we also need AE is going to match with CD. So that's good, right? We see the fact that AE is going to match with CD. Then we see the fact that we need BE, right? So we need BE. So we need this and this together, which matches up with that. So meaning our ratio is complete because we have 4 in total. We have like the pair of 2. Makes sense. So we know the fact that now we know the fact that AE, which is the blue one, divided by CD is equals to what? Is equals to EB divided by what? By CB, right? And our reason is going to be what? It's going to be that triangle EAB is similar to triangle CDB. Hope that makes sense, right? So we're going to have that. Then now we're going to take the previous ratio. So I'm going to just go up and take the previous ratio, which is the one that we proved. So I'm going to take this one. We need this one. So I'm just going to maybe cut this, just this. I just need this. Copy and cut, right? I need this ratio, and I'm just going to write it the way it is so that I don't make any mistake, right? So we know the fact that maybe let me just move it. Let me move it here. I'm going to delete it. So we know the fact that here from the previous one, it's triangle. So it's triangle CEB is similar to triangle CAE, right? Then we can delete this. So we know the fact that from this triangle, cut it, I'm gonna paste it just here, and maybe let's go back. I just want to make sure, because it's very easy to make mistakes. I'm gonna take this again, duplicate, cut. I just want to make sure the fact that everything is correct, because one mistakes. So C E E B B, then C AE. Okay, cool. So that's correct, right? Remember the fact that our goal is to find AC. So let's find AC. So we see the fact that AC is this one, which is going to match with EP, right? We need AC and EP, so they're matching with each other. But remember the fact that from this triangle, we also need this whole side, which is from this ratio, right? The one we proved, right? So we know the fact that we need CA. So we know the fact that we need CA. So CA, right? So CA is going to be this one, which is going to match up with this one, right? So now let's make that. So we know the fact that EP, right, is going to be divided by what? By AE, which is what we have. Then it's going to be CE divided by CA, right? Which is good. And our reason for this is going to be the triangle CEB is similar to triangle CAE. Hope that makes sense, right? Then now remember the fact that we need to equate this ratio to this ratio, right? So I'm going to name this ratio, right? So this is going to be 1, this is going to be 2. The reason why we need to equate them is so that we can have the square, right? So that we can create the square, right? So we see something, but we know the following, right? But we know that, so go back, we know the fact that these two are equals to each other. So we know that CE is equals to what? Is equals to CD. So we're going to use that CE is equals to CD. So here we see the fact that CD is this one and CE is this one. So we're going to make both of them the subject so that we can equate the remaining together, right? So taking 1 and making what? And making CD the subject. Taking 1 and making CD the subject. So that I don't make any mistakes, I'm gonna just copy it, duplicate it, cut it. So we know the fact that this, paste it here, move it here. So we're gonna make it the subject. We're gonna cross multiply. So it's gonna be EA multiplied by CB is equals to EB multiplied by what? Multiplied by CD. Make CD the subject. So it's gonna be EA. So it's gonna be EA multiplied by CB, right? And that whole thing is gonna be divided by what? Divided by EB, right? And that's gonna be equals to CD, right? So we're going to have that. So let's match it up. So we know the fact that EA and CB, that's correct. And we know the fact that CEB and CD, that's correct. So it's going to be EA and CD and EB. So that's correct, right? And I'm going to name this 3. Then what we're going to do now, we're going to take 2. So I'm going to copy this, duplicate it, cut it. We're going to take 2 now and make... So we know the fact that now we're not going to take 1, we're going to take 2 and make what? And make CE the subject. So we're going to make CE the subject, CE the subject. So what we're going to do is that we're going to take this one, duplicate it, cut it. So it's going to be like this, paste. Yes, so we're going to make it the subject. So it's going to be, since CE is at the top, that's great. So it's going to be EB multiplied by CA, right? And that's going to be divided by AE is equals to CE, right? So that's great. And we're going to name it as being equation 4. So now we're going to equate equation 3 into equation 4. So equation 3 is going to be this one, because CE and CD are the same thing, right? So duplicate it, cut it. So we're going to equate this to together. So we know the fact that this is 3 and this is going to be 4. Duplicate it, cut it. So we know the fact that this is equals to this, right? Then now we're going to cross multiply. So when we cross multiply, it's going to be EA multiplied by CB multiplied by AE is equals to what? Is equals to EB multiplied by CA multiplied by EB, right? So we're going to have that. We see the fact that this and this is the same thing. They just written in different order. So this is the same as EA squared multiplied by CB. And that's going to be equals to this and this is the same thing. So it's going to be EB squared, right, multiplied by CA, right? If you go back to the question, right, is that we want EB at the top and AC at the bottom, right? So what I'm going to do is that I'm going to cut this again because I want to have the question the way it is. Duplicate, cut it. So remember the fact that this is the goal. So let's have the goal here, right? So with the goal being in mind, right, is that we need EB. So let's write it the way it's written, like EB, right? So we know the fact that EB is written the whole right way, then AE. So it's AE. So we know the fact that this is the same as AE all squared. And BC is CB, which is, we know the fact that that's BC. So that's great. Then we know the fact that the other one is EB. So that's great. All squared. And that's AC. So I'm just writing it the way it is so that we can match it. We see the fact that we want EB in the denominator. So in this side, in the numerator, sorry, is this side, we're going to leave it the way it is. We're just going to leave it the way it is, right? So meaning this side, we're going to divide by AC, right? But what you do on the left-hand side, you need to do on the right-hand side. So this side is going to be what? It's going to be AC, right? Then remember the fact that this side is that we need BC to be in the numerator. So meaning we need to get rid of this one. So it's going to be multiplied by AE squared, then multiplied by AE squared. So now let's cancel out. We know the fact that these two are going to cancel. And here, these two are going to cancel. So we left with what? We're left with BC divided by AC is equals to EB squared divided by AE squared. Do you see the fact that that's exactly what we have? And you can just say, therefore, this one taking it to the other side, meaning I'm saying writing it the way they wrote it, which is going to be, therefore, that's going to be the same as EB squared divided by AE squared is equals to BC divided by AC. Hope that makes sense. So that's how you would answer this question. Hope that makes sense. So now we're going to do question 10. It says in the diagram below, PQ, so let me unzoom it, PQRS is a rectangle. So if we know the fact that something is a rectangle, we know the fact that opposite sides are equal, right? So we know the fact that this is equals to this, and this side, the whole side, is equals to this whole side, right? So that's what we know. So we also given by the diagram, we know the fact that that is 28. So meaning this is also 28, right? Then what do we also know? We know the fact that opposite sides are also parallel, right? So we know the fact that opposite sides are parallel. Also this side is going to be parallel to this side. Hope that makes sense, right? Then since also it's a rectangle, we know the fact that the corners create 90 degrees. So we know the fact that the corners are going to create 90 degrees. So we know that the corners are going to create 90 degrees, just like this, right? So I think so far we have all the properties that are related to what? That are related to a rectangle, right? Then they tell us the fact that, okay, cool, that is a rectangle. Then they tell us the fact that PR intersects, right, at X and Y at W. So we see the fact that PR, where's PR? So PR intersects here at W. So they didn't tell us it's a diagonal. We know the fact that we have one diagonal, that's it. But they tell us the fact that it intersects here. Then they tell us the fact that W, or what you call XY, so XY, this line is perpendicular to what? to PS. So it's perpendicular to this line, as we can see here, right? So we see the fact that that line is perpendicular. Then they tell us the fact that QY, so QY is this one, right, is 2, YR is 4 is 2, 4 is to 3. So I'm going to say 4x and 3x. So that's the ratio that they gave us. Then one more thing, they tell us the fact that PQ is equals to 28, and they tell us the fact that this line PR, so I'm just going to do it in red so that I can write how much is it. So PR, this line here, is also equals to 48. So this red line is equals to 42 units. So that's everything that we have in terms of the properties, right? So I don't think there's more that we can do. The only thing that we know the fact that this is also, this is going to be also 90, which is also, this is going to be 90, and this is going to be also 90. Hope that makes sense. Then I think we're done with the diagram, so we can go answer the questions. So now we're going to do 10.1. It says prove that xy. So we're going to highlight. We need to prove that xy. So xy is this line, right, is parallel to PQ. So it's parallel to this line, right? So there's two things that we can prove is that three properties. So meaning one is that we can prove the fact that this creates what? This creates 90. If we add this and this, it needs to create 90 degrees, which we can see that is true, right? And that is what? That is co-interior angles. So we can say co-interior angles. So therefore, these two are going to be equal to each other, right? And also, do you see the fact that you can also prove it by using corresponding angles, because this angle is also equals to this angle, and they both 90. So we have multiple choices, right? The one that we can't use is the Z, because we do not know what this angle is. So the Z one is 1, that's out. So I'm going to use the co-interior, right? The co-interior one. So I'm going to just draw a line so that it creates a U. So U is going to be the reason why those two lines are parallel to each other. So first we need to state how we know the fact that angle P is 90. Then state how we know the fact that angle S1 is equals to 90. Then we're going to basically say the fact that when you add them up together, it's going to be what? It's going to be 180 degrees. That is why they are the two lines are parallel, right? So first thing first, we know the fact that angle P is equals to 90 degrees, and that is what? That is angles of a triangle. So that's angles of a rectangle. They equals to 90 degrees. Hope that makes sense, right? Then we know the fact that angle S1 is equals to what? It's equals to 90, and the reason for that is going to be given, right? Then we know the following. We know the fact that angle P plus angle S1, X1, right, is going to give us what? It's going to be 90 plus another 90, which is going to be equals to 180 degrees. So that proves the fact that those two, when you add them up, they equals to 180 degrees. Then now you can state, therefore, that XY is actually parallel to PQ. And what is our reason? Our reason is co-interior angles, right? And since we're proving, let's say converse. Why can't I spell converse? Yes, converse, co-interior angles. So co-interior angles. Hope that makes sense, right? So that's how you would answer this question. So now let's update the diagram. We know the fact that these two lines are parallel to each other. So we know that these two lines are parallel to each other. Let's make it in green, right? We know these two lines are parallel to each other, right? And do you see the fact that this creates like two triangles? So it creates this triangle. I want to show you. It creates like this triangle, meaning proportionality theorem is going to play a role. And it creates another triangle, right? So it creates another triangle, which is this one, which also there, proportionality theorem can also play a role. Hope that makes sense. So those two triangles, the red and the yellow one, right? Now they say they tell us the fact that determine, right, with reasons the length of WR. So where's WR? So I'm gonna make WR in blue. WR is this one, right? It's this one. So WR, we need to find the length of that. But what do we know, right? From this is that we see the fact that in the red triangle is that we can find WR using proportionality. We given this ratio, which is great, meaning we can find, if we know what these two are, if we know the fact that what these two are, right, so we can find the whole length of that. So let's find the full length of that. We know the fact that the whole length of that, 4 plus 3, is going to give me what? It's going to give me 7x, right? Then here, the nice thing is that they gave me the whole length here, right? Meaning I can use that length and I can use this one to find it. So how I'm going to do the proportionality theorem is that it's going to be this one, the one that we want, divided by the whole side of it, which is 42 units, divided by the one, this one matches up with this side, then the whole side, which is the 42. Hope that makes sense, right? So using proportionality theorem, we know the fact that WR, right? So WR divided by the whole side, because of they gave me the 42, so divided by PR is equals to what? Remember the fact that we need to have one unknown, right? So it's going to be equals to, who matches up with WR, it's going to be YR. So it's going to be YR, right, divided by what? Divided by the whole side, because that matches up with PR. So it's going to be QR. And what's going to be your reason? Your reason is going to be proportionality theorem. And we know the fact that the two lines are parallel, that PQ is parallel to YX. Hope that makes sense, right? So hope that makes sense. Now let's substitute. So substituting every value that we have, right? So we know the fact that PR is 42, so it doesn't have the X. Then this one, since it's a ratio, we know the fact that YR is equals to 3X. Then QR is equals to 7X. The X's are going to cancel out, so this is the same as WR divided by 42 is equals to 3 divided by 7, right? Then now we're going to make WR the subject, so this is going to be WR is equals to 3 divided by 7 multiplied by 42. Then you're going to punch that into the calculator, right? So when you punch that into your calculator, we find the fact that WR is basically equals to what? It's equals to 18, right? It's going to be equals to 18. What did they give us the units in the question? 18 units. So it's going to be 18 units. So that's how you would solve this question, Anna. So now we're going to do 10.3, right? So before doing 10.3, remember the fact that we already found that this was 18. So we already found, we already found that that was 18, right? So we already found that this portion here is 18. Why am I updating it? Is that if we know that this portion is 18 and we have the entire part as being what? As being 42, right? To find this portion here, right, we can find it. So it's going to be 42. So when you take your calculator, right, when you take your calculator and say 42 minus 18, right, you're going to get 24. So we know the fact that this portion here is 24. So we have updated the entire diagram with the new information that we have, right? So now let's answer the question. They say the fact that determine the length of XW. So XW is going to be this one, right? So we see the fact that XW from this triangle, and I'm just going to do it. Remember when I was doing it is the yellow triangle. From this triangle, it's from this yellow triangle, right, is that if we look at it closely, right, is that when doing the ratio, we can't do the ratio of the base. So we can't use proportionality theorem on the base. So meaning this yellow triangle can't play any role, right? But what do we know? We know the fact that the one that we can do ratios with related to the base is what? It's proving similarity theorem, which goes proving that two triangles are similar. Then from proving that two triangles are similar, then we can basically find this value. Hope that makes sense. So what do we know? We know the fact that we can prove, right, that this small triangle here, which has our xw, is actually similar to this big triangle here, right? So I'm going to do this triangle. So I don't know whether we're going to see it or not, or whether you highlight it or not. So we know the fact that the big one we're going to say is the yellow one. So it's going to be the big one is similar to the small one, which is going to be this one, the blue one, right? So we're going to prove that those two triangles are similar. And we can actually do that. One, we see the fact that P2 is common, which is perfect, right? Then we see the fact that this one is equals to 90 that was given. And also this one is equals to 90. Because of that is what? We know that these two lines are actually parallel to each other from the properties of what? Okay, cool. We first know the fact that these two are parallel, right? And the reason why we know that those two are parallel is because of these properties of a rectangle, right? Then we prove the fact that this line is equals to parallel to this one, which by default, this one is also parallel. Hope that makes sense, right? Or you can just make it simple. We know the fact that this is 90 degrees, properties of a rectangle, which is going to be equals to this one, which is given. Hope that makes sense. So I think I'm going to just take the simple one of that one and like matching it up of the two are parallel to each other. Hope that makes sense. Then the remaining ones are going to be equals to each other, which now makes it sum of angles in the triangle. So now let's do it. So we're going to say in. So in, okay, cool. So black. So in and triangle. My triangle that I'm going to pick is going to be what? It's going to be P. So it's going to be PXW. So remember it's PXW, right? So we know the fact that this one, meaning the next triangle, we need to start with P because P is equals to P. So it's going to be another triangle, which is going to be P, right? Then P is going to be equals to what? To P, then X, right? Our X is equals to S. So it's going to be S. Then we see the fact that our W is equals to R, right? So it's going to be R, right? So remember the fact that we need to match because of the ratios we're going to take from here. Hope that makes sense. Then we know the fact that the first statement is going to be that angle P2 is common, which is great. Then the second one is that we know the fact that angle X1, right, is equals to 90 degrees, and that's given, right? Then from that, we also know the fact that angle S is equals to 90 degrees. And remember the fact that that's like properties of what? That is angles of a rectangle is equals to 90 degrees. So I'm just going to copy and paste this reason. Right? Which makes now angle, therefore, which makes angle X1 equals to angle S. Then lastly is that we know the fact that angle W1 is equals to angle R1. And our reason is going to be W1 is equals to R1, sum of angles in a triangle, sum of angles in triangle, right? So therefore, we know the fact that what? Triangle PXW. So we're going to know the fact that angle PXW, so it's going to be angle triangle PXW is actually similar to triangle PSR. And our reason is going to be angle, right? So we know that. So remember the fact that the goal is to find what? So we know the fact that the goal is to find this one, right? So to find that one, which is wx. So now we know the fact that wx, I'm going to take it in red, wx matches up on the other side, which xr, right? Then we look at our triangle and see what do we have, right? We know the fact that wx matches up with sr, which is perfect because we have 28, right? Wx should be the only one with them, what you call this, should be the only one, right, with that should be unknown. So what other side do you know the fact that we have pr, right? So we know that pr, so pr, we already know that's 42, right? PR matches up with pw, which is perfect. So PR is this whole side, which is 42, and PW is this side, which is 24. So we know the fact that XR is the only unknown. So we know the fact that XW, right, divided by what? Divided by XR is equals to what? To PW divided by PR. And our reason is going to be what? That triangle PXW is similar to triangle PSR. Hope that makes sense. Then now we're going to substitute XW, then XR is 28, right? And we know the fact that this is 28. How do we know the fact that that 2 is 28? Is that opposite angles of what? Opposite angles, what you call this, opposite of a triangle are equals to each other. So I think before even doing that, let's write that, but XR is equals to what? XR is equals to PQ. And the reason for that is going to be what? Opposite side of a rectangle. Opposite side of a rectangle is equals. Hope that makes sense, right? So now we have everything established, right? In terms of properties, why we're saying everything is equals to its value. So now let's substitute. We know the fact that XW is equals divided by 28, and PW, we know the fact that PW is 24. Then we know that PR is 42. So we have that, right? So we have that. So now we're going to basically make XW the subject, right? So making XW the subject, so it's going to be XW is equals to what? Is equals to 24 divided by 42 multiplied by 28, right? 24 divided by 42, then 28. Punch that into the calculator. We see that XW is actually equals to 16 units. So that's how you would solve this question. Hope that makes sense, Anna.